again.
Yes, yes. And so today we're going to be talking about the scientific method. But before we get into that, I think we should talk about our week, right?
Oh yeah, absolutely.
Most definitely. So, I mean, how's your week been?
Well, the second week, right? Yeah, second week of school. Yeah,
Yeah, it's the end of the second week of school.
end of second week of school.
Yeah.
I feel like slowly things are settling in. The schedule started like fitting together.
Yeah.
It is definitely still busy. I mean, it's not as busy as probably mid or finals of the semester, but still slowly piling up. The assignments started stacking up now. So
Yeah, it still feels really busy though, because like you're figuring out like how your professor is, the sort of type of assignments you're gonna have, and you're just trying not to have a panic attack.
yeah, especially since you have so many involvements on campus. So
Yeah, for sure. So, so what classes are you taking this semester?
so DPQ,
Okay.
engineering probability and statistics.
Okay.
What else? What else? I sadly couldn't. Oh, mathematical physics.
Okay.
And one more.
One more.
It's in the top of my head, but I couldn't remember. Electrical sciences.
Okay.
What about you?
Nice. Well, first let's do a quick introduction of ourselves.
Oh yeah, that's true.
So introduce yourself.
So my name is Albert, and I'm a biomedical engineering major, and this is my third year
Okay.
in UCO.
Nice.
And I'm by credits I'm a senior, but I have technically a year and a half left.
Okay.
Yeah.
Okay. Nice.
How about you?
Yeah. So let's see here. I'm a computer engineer. That's the program I'm in, right? I started as a computer scientist, and then like wavered to engineering physics, and then I was like, well, I really do like computer. I love computers. I love technology. So I was like, let's get into computer engineering. And I mean, there's so many engineering jobs out there that I was like, let's do it. And with the advent of like AI and the need for more GPUs,
the hardware, exactly. I feel like that's understated. Everyone's going into like data science, computer science, like software side, but there's not enough people going into hardware.
Yeah, for sure.
Yeah.
And so, computer engineer, and then also I do research under Dr. Tej Lamajani. So his research is in material science. Mine is specifically in applying machine learning to material science. So trying to discover a new material using machine learning, which for me is like really a dream, dude.
Yes.
I mean, AI to me is, so I want to understand the world as deeply as I can, but I also want, us as a society to understand the physics and how the universe works deeper, right? So that we can manipulate our environment better, more sustainably, and then hopefully, get cranking on the Kardashev scale.
Kardashev scale, that's awesome.
Right? You want to explain what the Kardashev scale is?
The Kardashev scale basically is a hypothetical civilization scale that talks about progress, but mainly it's based on energy consumption. If you're Kardashev 1, that means you fully utilize the entire planet's resources, especially its energy. Then Kardashev 2, you're fully utilizing the entire solar system's energy. Kardashev 3 is the entire galaxy.
Okay.
So, yeah.
Awesome. Yeah, I mean, whenever I first heard of the Kardashev scale, I was like, oh, like people are thinking a little bit more deeply about this than what I thought they were. Yeah, and it's just fascinating to think that to me it's a way to look forward and to see what could be possible.
Yeah, it's anticipating the future. I think that's what makes it very exciting.
Exactly. And so okay, yeah, my research, and then so I'm also the president of Physics Society. This is the vice president.
Yep, vice president.
And so yeah, we did a lot of work this summer for Physics Society trying to sort of pump it up more, right? So we made shirts. So if you have seen the shirts, just so they're only $25.
And they're in the Discord.
Yes, and so they have this logo on them, Physics Society, with our beautiful black hole behind the Physics Society logo. And then on the back, there's a quote that says, which I love this quote, and it's up in Howe Hall. And it wasn't the first time, whenever I saw that in Howe Hall, it wasn't the first time I've seen that, but I think for me, I love seeing that every day. And so I was like, well, we got to put that on the back of our shirts.
Yep.
And so the quote is from Albert Einstein. I have no special talents. I am only passionately curious. Yes. And so, I don't believe I'm an expert in anything, but I do have like an unwavering curiosity, passionately curious, right? So, I mean, I think that's why we wanted to start this is, to sort of help us, talk about the things that we're curious about. Because, you may have a lot of ideas, you may have a lot of curiosities, but you never really know if they are actually good ones until this is how I feel anyways, until you actually speak them out loud.
Yes.
Right? Because sometimes you can have this like
good thoughts, good ideas, but it doesn't sound good out loud.
Yes, exactly. And I think that's how you know when an idea is, good.
Especially since you have someone to discuss with, and especially you get feedback, constructive feedback, hopefully. And then I think this also serves as a good platform for other people to come and discuss with us as well. I think that's very important.
Yeah, and every semester I feel like I have sort of been like missing something, right? Like I had, making good grades, learning a lot of stuff in school. But, and then, I started doing research and I thought like, oh, that's the thing that's going to fill the hole that I've been searching for, right? But I think this is that thing that's going to actually finally fill the hole that I have of just sort of exploring different ideas. We don't, and we talk about this all the time, right?
Yes.
Like school doesn't necessarily teach you everything you're going to need to know when you go out into the real world and find a real job, right? Of course, they're going to teach you a lot of those things, and of course, you need to have a background to get that job. But there's still a lot of things you don't know about, and so a way to make myself learn other things and try to learn them more deeply, I think this is a good way to do that.
Yeah, I agree. I feel like half of the things that we have to learn is like from our everyday life. And I feel like if we read books all the time or we do research and even like just talking to somebody, I think we will learn quite a lot of insights from them just from a conversation.
Yes. Yeah, well, I think, and he's an astrologist or a cosmologist. Anyways, his gripe about scientists is that they don't communicate their ideas to the public very well. And I love physics so much. I love the research that I do. And I'm always trying to figure out a better way or a way to better get that message through of why that is so that it's needed, right? Why my research is needed, why engineers are needed. And so yeah, I'm always trying to find a better way to communicate that, because I know that at the end of the day, right, nobody's gonna care unless you're able to show them why it matters.
Exactly.
And you can't do that if you make the way that you talk about your research or whatever it is you're interested in or whatever it is you're trying to get money for to go and do. You're gonna have to like hype up the public about it, right?
It's true. Yeah, it's true. I mean, it's like going to class. If your teacher is like kind of like monotonous and like low energy when he's talking about what he's talking about, you won't feel interested. I've had a few professors that are genuinely passionate about what they're teaching. it makes the entire experience so different.
Most
Like, it makes me want to know why he likes it so much. You know?
Most definitely.
Yeah.
That's like, our guest last Friday, Professor Prather. I've had so many interesting conversations with him, like so many. And that's why I wanted to get him in. And that's why I was like so pumped about having him in last Friday and him like saying, yeah, I'll do it, is because I know it's going to be a great conversation. It's going to be fun. It's going to be interesting. And I know I'm going to learn something.
Yeah.
And one of the things that makes me learn more from him is just his excitement about it.
Exactly. Yeah.
Right. And his teaching style in class is like that. It's one of the reasons he's very approachable, right?
They're very interactive.
And so it's, I think sometimes I don't go and talk to certain professors, because I think you definitely should, right? You should go talk to your professors during their office hours and ask them about problems that you're having with the homework or whatever in that class. Not only to try to learn more about them or about the material, but to also to build that relationship, right? Because that, I mean, of course, they're not going to give you an A just because you have that relationship, right?
Yeah.
But it's definitely going to make that process of that semester go a lot smoother, right?
It's true. Yeah.
And then maybe you start a podcast and you're able to ask them like, "Hey, would you want to come on the
That's true.
podcast?" Right?
That's what happened last time. That's true. That's true. I mean, I feel like, especially what we're going to get into today, scientific method. Inquiry. The important part of inquiry is that you can have a conversation and ask somebody about something. And I feel like if you know your professors well, especially since your professors usually know what they're talking about, I hope. Otherwise, they won't be professors. They, especially most professors do research on campus. So if you talk to them about what they do and what they know, especially if you really show that you're curious, I feel like that's the only way they would be willing to share with you their wisdom and knowledge. If you're asking half-assed questions, my language, but like, I wouldn't think that they would be that enthusiastic in answering. So I feel like it takes both sides. One has to be very passionate about the questions. The other one needs to be very passionate about their teaching.
Oh, for sure. Yeah. I mean, if you're not passionate about what you're doing, you're not going to go and talk to the professor, right? You're just going to go home and ask ChatGPT what the answers are and just get on with it, right? You're not going to worry about actually trying to understand the material. But so let's see here. So what else am I doing? So let's see. So we started the podcast. Every Friday we're doing this podcast, right? We're trying to get on more professors, more experts, right? Or just more curious people, right? And so yeah, I mean, I don't even know where I was gonna go with that. But yeah, so we're doing the podcast every Friday. And what else am I? Oh, I have a conference that we're going to October 26th to Palm Beach. Super pumped about that. A week-long conference where we're going to just nerd out about magnets.
Oh, that would be awesome. Yeah.
And what's really cool is I'm going to get to meet like some, sort of experts in the field of magnets. And last time, I'll be honest, like I was a little... I want to say, I was a little scared to go up and talk to some of these guys. They're, they've been working on magnets for a very long time.
For a large part of their lives.
Exactly. And I'm just a novice, right? I just started this, been a little bit more than a year now. But I think this conference, I'm going to try and reach out more. Maybe even try to do a podcast or something.
Yeah, that would be awesome. Yeah, that would be awesome.
For sure. But let's see, what else? So the conference, and then, so last year I got awarded or selected by UCO to go to Oklahoma Capitol Research Day.
Ooh.
That was really like one of the coolest things that I've done so far through research. And that's why I say like go and do research, because it really can open up doors. Even I hear this all the time from students like, oh, well, I'm not smart enough. I'm not far enough in my studies to really do research, but neither was I.
That's the whole point of research, by the way. It's like you don't have to know everything. The whole point of research, a large part of it it's called literature review. It's literally to learn and catch up with what people already discovered. So I feel like people often underestimate what they can do just because they haven't done it yet. You know?
Oh, for sure.
Yeah.
Yeah. I mean, you know, the first semester, so I started doing research the last summer, right? We started last summer, and then we just we worked hard all throughout that summer, and then we applied to different conferences, and I got selected to go to all of them. I went to APS Dallas, and that was a extremely eye-opening experience, right? Like I was only
I heard that there's a lot of people there.
yeah, American Physics Society, and then there's like different branches, right? So for different regions of the United States, and so I believe ours was called like the Texas something region or whatever, but now they're trying to make it sound more like it's Texas, Oklahoma, Arkansas, because they're getting more people to come. Yeah, exactly. And so that was my first conference, and no, it wasn't really big, but it was. There was still, probably 100 or more people there, right? And so, I got to talk to cosmologists and a bunch of different researchers in different fields, and then I also got to sort of connect with Dr. Teo. Dr. Teo was our sort of I want to say like, well, he went down there. I forget. Dr. Tej was there as well, but you then get to spend a lot of time with the people you went down there with, which is a really good like relationship building, and you get to learn more. I learned a lot about Dr. Teo and his research, and then let's see what else. And so yeah, you just, because there's so much different research that's going on around us, and it's really interesting research. That's why I think that's where I started saying like the most interesting people are the ones like right around you, because yeah, when you go to a conference and you see like these people are either from Texas, Arkansas, or Oklahoma, and you see the research they're doing, and it's like so interesting. You're just like, oh,
And it just flies under the radar.
Yeah, exactly. This one guy was doing research on it was like, so they were using rats, right, and they were rubbing something on like the tummy of the rats to basically make it translucent so that they could see the insides of like the stomach, so that they could better put sensors and see like the digestive tract and how it's sort of working
without being invasive.
Exactly.
That's cool.
Exactly. And they were even able to do it on the skull as well.
That's awesome.
Yeah. And so Anjali really wanted to talk to him. So I started a conversation with him to try to get Anjali.
Yeah.
Anjali's more of an introvert than I am.
Yeah.
and so yeah, and so that was my first experience at a conference, and it just sort of opened my eyes, and I felt like the most novice person there because we just started, but everybody was just so excited to hear what you were doing, to share what they were doing. And no matter where you were at in your research, but we got the opportunity as novices to go to Dallas, to then go to New Orleans at the MMM Magnetics Conference. And yeah, so that's why I just try to tell as many people as I can, go do research.
Yeah,
right?
research isn't just about like sitting in a lab or just writing papers. You do a lot of things. You can travel around the world, meet people who's already far ahead, and they can give you guidance in what you're doing. You don't have to be the best at writing or presenting. You learn along the way. That's the whole idea of research and science, is that you don't know something. That's why you want to learn it.
Exactly. Yeah, so many doors have opened up because I just said, okay, let's go do this thing.
Yeah.
Right. And I'm one of those kind of people that like, if I'm going to do something, I'm going to do it to the fullest. Right. So I'm going to work as hard as I can. And I could have probably worked 50% of what I was and still had those doors open up.
Yeah.
Which is still kind of insightful. Yeah. And so, like I said, I got to go to Oklahoma Capital Research Day. Hopefully, I get selected this year as well. That was, for me, like a really growing experience. It showed me that, oh, I have to work better at my communication skills. I'm really bad at talking in front of a group of people. I get
Really?
so nervous. Yes. Whenever I gave my first talk in front of Physics Society last semester,
Oh, I remember that.
I was so nervous. I thought I was going to have a panic attack.
Yeah.
Like literally.
You did amazing. I think you did
Thank you,
amazing.
thank
Yeah.
you. Yeah, it was on the easing model and how it sort of applies to my research. And so for me, I always like to talk about the history of things.
Yeah.
And so I started off with like the history of, how we got to the easing model. And so it sort of starts off with statistical mechanics and goes from there. And so yeah, a lot of people talk about this, and it's like you just got to get involved, right? Oh no.
Did we not record the audio the whole time?
Yeah, well, we're recording it on this.
Okay,
But here,
so-
let's go ahead and plug this in. Sorry, guys. Oh no, that's plugged in. Oh, but I wonder if we can hit that record. Card. What does it say? Card protected.
Oh no.
I think it'll be fine. But we're
But we're
recording
recording
on
there.
this. Card protected. I don't know what that means. I don't know.
Where's Brody when you need him?
Yeah. Oh, okay. Yeah.
Yeah.
So speaking of, let's
Yeah.
shout out Brody. So I've been the one editing the podcast, and we've talked about this, and I'm sure it's a lot of work.
A lot of work.
So much work. I probably spent, I don't know, anywhere from 8 to 10 hours on it last weekend, and I don't want to go into the details of it, but it takes a lot of time. And so I was like, you know what? I'm going to reach out to the Discord and see if anybody would like to, volunteer and help us with editing the podcast and also like our lecture videos that we do, that we record. And so I got 2 emails, and Brody was one of them. So Brody Smith, who I forget what his major is. I think it's like production major. So his, I believe he goes to ACM, which is the School of Music, or what is it?
So it's downtown downtown OKC, and it is the campus for music and the production majors and audio production majors and stuff.
Okay, yeah,
Music production major.
So he emailed me, and thank you, Tyler G. I don't know Tyler's last name, but he's on our Discord, and I believe he's like a Prather was telling me that he's an engineer / like musician.
Wow.
Yeah, so he knows. Maybe he would be a good guest for when we go into like music, the physics of music and things like that. Because apparently, I think Prather said that he makes like his own pedals and stuff like that.
Oh, that's cool.
I think Tyler, reach out please, and maybe I need to touch base with Tyler and like make sure what he really does. But anyways, so Brody Smith reaches out, emails me, says, hey, I wanna meet up with you and talk to you about this because I think I would like to volunteer to do this. So we meet up, I believe, what was it, Tuesday or Wednesday? And we're just sort of talking, and yeah, so he's a really cool guy. He's really easy to get along with. I think he's going to be a really good part of the team. You just met him today.
Yep,
You
he's
guys
very cool
get
guy,
along.
very fun guy.
You guys get along really well. And yeah, I love it. We came in today, and I was like, here's our equipment, and I was talking with the guy up at the front desk over here. And he just got to work.
Yeah,
he
just got
started
right into
taking
it.
out, putting everything together. Such a big help, and
He even gave a lot of technical advice and like show us how it's done.
Yeah,
Very chill guy, very cool guy. It makes it very entertaining and fun too.
Yes, and so I'm just pumped for that. I'm excited to see what the end result is going to be, and yeah, I'm so pumped that there's people out there like us who are curious and just down to get the experience.
Yeah, get our hands dirty, you know.
Yes. Yeah. So, I want to tell this to everyone out there too, and that maybe is a part of Physics Society and wants to give back in some way, right? We are totally willing to open our minds up to new ideas and new things that could help us sort of,
Expand the horizons of Physics Society.
exactly. That's a good
And
way to say
we
it.
hope that we can make more people curious about physics and science in general and research as well.
Yeah. I was thinking about this the other day. I was like, man, Physics Society, we're creating jobs out here.
Yeah,
I love it.
I mean, to be fair, you guys started it like last semester.
Yeah.
Officially, we started last semester.
Well, so like Dr. Teo has been sort of carrying the torch for probably as long as he's been here. I don't really know. That would be a good conversation to have with Dr. Teo.
Yeah.
But so it used to just be the lecture series, right?
Yes.
So
Only the presentations, the lectures.
so whenever I first got here, Dr. Teo was like actually he was like my advisor, because I said I was gonna do engineering physics, and he's the advisor for that. And so he was one of the first people that I talked to at UCO. And he's just a very interesting and curious person that we just sort of like hit it off, right off the bat. And so I don't know how I learned, maybe in that conversation or maybe in another conversation that we had about the lecture series that he was having. So every 2 weeks we had, someone gives a lecture, students, professors. We're always trying to get more professors and students to help them with communication, right? Especially students. I mean, I'm sure a lot of the professors out there that we've had give lectures are really good at communicating their ideas. But Dr. Teo has sort of said, hey, we would like to give students the opportunity, which we took last semester. And like I said, it was very nerve-wracking for me. You just shine, dude.
I appreciate it.
You were just so natural up there. It was the funniest. Maybe not fun. It was funny, but it was like, I loved it. Your just
appreciate it.
excitement, your curiosity, your ability to just like pull out these like very complex ideas out of your brain and say them in a way that people can understand is just, to me, like one of the I don't want to say it makes me jealous, but like I wish I could do that.
I appreciate it.
But so I started going to lecture series and started being more part of Physics Society. And Dr. Teo had talked to me early about, well, Physics Society needs a president, right? It needs a leader. And I sort of brushed it off in the beginning because I just started being an engineer, right? And all of the classes, like I think my first semester I took 17 hours. And that was
hectic.
That was crazy for me, because before that I was taking like 6, 5, just because I was working.
All the way,
I was working and going to school at the same time. And yeah, like I said, I hopped all the way up to 17 hours, and it was just like really overwhelming at first. But, I started to get good at it. I started to, I started to need another challenge. And so that's when I started research. And then I was like, well, it seems like I've got this too. Okay, research,
and it's
school,
connected.
I got this. Yeah. And I was like, well, I want to give a talk and about my research, and I'm always at the meetings and stuff. I might as well be the president.
Exactly.
Right?
And you talk to Teo all the time. And I remember the other day, like, you came into the lab, I was there, and then you're just like, hey, Albert, Dr. Teo was just talking to me about Physics Society, and he says that we need people to help out and whatnot. And you even asked me if I wanted to join Physics Society, and I think that's when we actually like started putting things together. And officially putting it as part of UCore and everything.
Yes.
I remember good old days.
Yeah,
I mean, just a semester ago, but it's crazy.
whenever I first started, I thought like, okay, this is gonna be pretty chill,
Yeah.
like whatever. There's probably not gonna be too much to this, but then you start to find out that in order to register
Yeah.
through UCO, you
It's
have to
quite tedious.
You have to jump through some hoops, and they're not that bad, but they are hoops
For sure,
and
for
there's
sure.
it's definitely extra things you need to do, but I was fine with taking on that responsibility.
But I think what gets exciting is when we start getting into the actual events itself.
Yes.
The tabling, at first we thought we were just going to sit there and just wait for people to look at us in the eye. Well, everyone's walking by, not batting at us. And then while we're sitting there, we started getting more ideas on what to do and whatnot. And then, I don't know, on the day of tabling, I had so much fun.
Tabling?
Remember the outside? Yeah.
Yeah, having people come by.
Yeah.
We had our shirts out.
Yeah.
Hello, space travelers. Want to look sharp while bending space time? We've got brand new Physics Society t-shirts. The clean graphic tee is just $20, and if you want to drop some Einstein-level wisdom on the back with this quote, "I have no special talents. I am only passionately curious," that one's only $25. Rep your curiosity, rep the cosmos, and support the Physics Society. Grab yours today before entropy takes over.
Shirts out.
Yeah, that was crazy.
We had our mics.
Yeah.
Yeah, and it was cool to see that there were people interested
Interested.
like people. There were certain people that came up to us and it was like, "Oh, this is exactly what I was looking for."
Exactly.
And that just
That's what tickles my
I
brain.
wanted to cry. I
Yeah.
was like, "Oh yes,
Yes, we did it.
Yeah, because that's one of the things why I was like, yeah, let's try to build this thing up because I want to meet more people like us, right? I want there to be a platform for nerds to come and nerd out.
Exactly.
Yeah.
And there were even people that are not from STEM majors who came up to us and be like, "Oh, I'm not really that good with science, but is it okay if I join just to learn, just to listen?" And we're hell yeah.
Yeah.
That's the whole point of Physics Society is for you to learn. It doesn't matter what major, what background you're from. If you're curious and you want to learn and you want to share,
Yes.
this is the place you want to be.
Exactly. And so yeah, my whole way to just go about life is just to do and not think too much about it. Because if I start to sit back and think about all the responsibilities I
You'll
have,
overthink it.
oh my god! Not only that, but like I'll have a panic attack.
Yeah. What I said last time. What is it called? Paralysis by analysis? Yeah.
Yeah, but people for the longest time, I kept listening to people for the longest time talk about like follow your curiosities, and I envied that. I was like, I need to do the same thing. I think for the longest time I was just, I don't know,
Drifting through life, sort of. I
yeah,
agree.
sort of, and so I was like, you know what, I'm gonna finally do that, right? I'm gonna finally just follow my curiosities, and no matter how much work I end up, putting on in my backpack and hauling with me, like I think it's all gonna be worth it.
I agree.
And it's been worth it.
It's so far been very fulfilling, in my opinion.
Yes, yeah. I mean, I wake up every day and my brain just like takes off. I'm like, okay, I gotta do this, but like I'm excited to do it, right?
Yeah.
Like today I woke up
You
and I was
want to
like,
wake up.
I was like, okay, we got the podcast today. I gotta get ready. I gotta do my workout, make sure my brain and my body is like good to go. And yeah, now we're here.
Now we're here. Yeah.
But anyways, I think we should get into the scientific method
Oh
finally.
yeah.
As long unless there's anything else you'd like to talk about.
Not at the moment.
Okay.
But I do want to say, if you guys are interested in any research or the lectures, do follow our Instagram and also join our Discord. That's where we'll be announcing more events in the future, even potential giveaways like last time. And a lot of the lectures and even the podcast episodes, we will be posting it in the Discord and Instagram. So
Yeah, for sure. We want to make everything that we do
transparent and accessible to everyone.
exactly. And so yeah, so let's get into it. So the scientific method.
Yes.
So like you said earlier, there's It doesn't seem like there's a lot that you can talk about the scientific method about, but there is. I think there is. You know, there's not only the history, right? So what I love, I wouldn't say what I love most, but I find it so fascinating.
How we got there in the first place.
Yeah, exactly. I think sometimes the history can add the human aspect of it, right?
Yeah.
And you can see the flawed humans that sort of have helped push, you know, humanity forward. And you say, oh, okay, if these people are flawed, and maybe I'm a little flawed, then maybe I can do this.
Yeah, exactly.
Right.
Yeah. I feel like it gives us a different perspective and sort of like a new level of respect to the scientific method. A lot of people who knew little about the world, just curious and started establishing like, okay, here's what we know, here's what we don't know. How do we know more? And I feel like that's kind of fascinating, especially since if you read into it, it's scientific method goes back to the ancient, like Egypt and ancient Greece.
Yes. So I couldn't find anything that was really well, I don't know. Okay, so this says it says and I believe this is in chronological order, right? So it says ancient Egypt and Mesopotamia. So that definitely comes before the Greeks, right? Because
yeah, pretty sure.
I wish we had a better timeline of this, but anyways. So it says practical empirical methods in medicine, engineering, and astronomy. Egyptians papyri outline diagnosis and treatment. Babylonian astronomers predicted eclipses with systematic data.
Right.
Yeah, so I wonder if it was one of these guys who. Actually, it was Thales. So Dr. Prather was telling me to look up Thales, and apparently he was the guy that predicted the first well, not the first, but he was the first one to predict a solar eclipse or some type of eclipse.
Like
And
consistently?
I don't know if it was consistently. I think that I mean, I would think if you could predict it once, you could predict it again, right? And so is Thales? It sounds Greek, right?
Yeah, it sounds like it. He's a pre-Socratic philosopher.
Pre-Socratic. So that's I don't want to say pre-Greek philosophy, but that sounds like what that is.
But he is. It's pretty interesting.
So, anyways, so yeah, you have the ancient Egypt and Mesopotamia, which we'll actually get back to because. So I was watching a video the other day, and it was about this guy, Ben. What was it? Ben Halzon. Oh man, I'm gonna butcher this. I wish I had it.
Which one?
Let's see here. I gotta look it up. Let's see. I was watching a YouTube video about the scientific method. It was from PBS, right? And it was talking about one of the first guys to use the scientific method. So apparently, from what this video was saying, is that the Greeks are sort of known for building the logical structure,
framework.
Yeah, sort of the way to logically break down a problem, right? And then apparently this guy in Egypt then took that a little further and used that same logic, but then added these like steps to sort of build up or so he used the hypothesis. So talk about the scientific method. So what does the scientific method consist of?
So it started off with a hypothesis, right? Wait. Let me make sure like I'm not like butchering the scientific method.
Yeah, because
there are several formal steps.
There is.
Define a question. Organizations, factors, center inquiry.
Yeah, here we go. Let's do this one because this is the one that Prayler was telling me seemed to be like the most
Well defined.
well defined. So you start off with so there's three different groupings, right? There's plurality, proof, and pure acceptance.
That's the best one, yeah.
And so it starts off with plurality, which the first step in plurality is observation or domain observation. So you, it's funny because Feynman, his first step is a guess. You take some guess, but to me that doesn't make too much sense, right? Because the only way to make a guess is to have had some observation, right? You can't guess something if you've never sort of observed it, right? And so yeah, you have the observation, and then it says intelligence gathering, schema construction. So that's like data collecting, right? So you collect a bunch of data that I would think would be related to the observation that you made.
You're gathering data and
Necessity, establishment of necessity is
why we need it.
Exactly. So Prather was saying, like, so there's no paper out there that, or at least I don't know of, and maybe he doesn't know of, but there's no paper out there that explains why the sky is blue. Like, everybody already sort of knows why the sky is blue.
Yeah, Rayleigh scattering and whatnot.
Yes. And so there's no really like necessity to sort of
write a paper that sky's blue because of Rayleigh scattering.
yeah, exactly. And so you have to have some necessity, right? You have to have a reason for why this science is actually going to be important. And then construct a formulation. So is that like, what do you mean, like construct formulation?
I think it's like that's where you start formulating the theories for. No, actually, no. That's hypothesis development. No, I would think.
I'm gonna ask ChatGPT.
Construct formulation. Oh no, it explains it right here.
Oh, does it?
So what alternative placeholder ideas can be established which could theoretically resolve this? How can this idea be constructed in a Wittgenstein-defined, rigorously logical form and be interrelated with prior art?
Interesting.
That's crazy.
Oh, okay. Well, let's go through this.
Yeah, let's go through that.
So let's go back up to observation. I'd like to read some of these questions off. So, what prior art has been developed inside the observation domain? Prior art has been developed?
Okay. This is what I'm thinking.
Yeah.
When they mean art, I think they mean model.
Okay.
What prior model that has been developed inside this observation domain? So, like, let's say we see the sky is blue. What prior model has been used to explain this?
Okay. Yeah, that makes sense. And like, how can you sort of like poke holes in it? Right?
Yeah. And then what do we not know about this topic?
Yeah, that's a good. Yeah, I mean, you always want to make sure that whatever thoughts you have, right? You want to, or like, for instance, in senior design, right? Where I'm in my first semester of it, and the first task we have is to come up with an idea and basically sell it to the group. And you may have an idea, but that doesn't necessarily mean that it's never been thought of before, right? And so it needs to be a novel idea. If not, because if it's not novel, why pursue it, right? Unless you're trying to replicate it for some, I don't know, research. Hey, Brody, we need to plug the phone in. There should be a
Yep.
Yeah, there should be. No. There should be a white extension cord in the box or somewhere. Okay, awesome. Thank you, Brody.
Appreciate it.
But let's see here. So yeah, what do we not know, right? We need to make sure that the thing that we're doing is a novel, right? And then what is the neglected or embargoed observation set?
I think this is what I mean is what observation have we taken for granted?
Okay.
Like we just brushed off. Oh, the sky's blue. Okay.
Okay.
Just is,
okay.
you know, just sort of is.
Yeah. Okay. Huh.
I think that's what I think it means.
Hmm.
See, and knowledge that is or knowledge that's forbidden. So like people sort of like taboo that knowledge. Like for example, back in the day, we thought Earth was center of the solar system, and if you think that the heliocentric model is right, that's illegal back in the day.
Yes.
That's why Galileo got prosecuted. So I think that's what they mean: neglected or embargoed observation set.
And then it says, what observation does skepticism mandate? What observation does skepticism mandate? Go and look, it says.
So I think observation.
Observation does skepticism mandate?
I think it just means.
Interesting. That's an interesting question.
What observation does skepticism mandate?
Observation does skepticism mandate? Okay, so oh my bad.
I think it's like where else do we need to look? Type thing.
Okay.
Like
So
what else? What other what do we need to question? That's
Okay.
why I think.
okay, yeah, it says you don't just accept claims on authority, tradition, or intuition.
Exactly.
You go out and you observe and you measure, check
Question
reality.
it, challenge it.
And so let's see what this means in practice. So domain observation. Skepticism demands that before forming any belief, you look at the phenomenon as it really is, not as you've been told
Yeah.
it is. Yeah, and that is, man, so many times, and I can't think of an example off the top of my head at the moment, but so many times somebody will say, "Oh, this is just how it is," or they say something, and you know they say it in such a way that it sounds like you shouldn't question that.
Yeah.
Like because there's some authority or
Yep.
some expert in the field, right? But I think I think it's healthy to ask dumb questions, right? Because for me, that's how I learn. I have a lot of dumb questions in me. I'm not gonna lie. And maybe, they always say like there's no such thing as a dumb question, right?
But let's be honest.
Let's be
Let's be
honest.
honest. I don't want to be that guy. But like, I mean, if I think the right way of saying it is if you have a genuine question, you should ask it.
Yes.
No matter how seemingly dumb it is. I feel like as long as it's a genuine intellectual question, as long as it's not a mockery question or a sarcastic question, I think it should be a genuine, I want to know question.
Yeah.
It doesn't matter how dumb it is.
Yes. But sometimes in class, my I want to say, whenever I'm in class, I'm typically, and I'll just be honest, I'm typically the only one asking questions.
I remember that.
And because, that's how I learn. And even if, sometimes I ask a question that I really should or I do know the answer to, but hearing, and let's say I ask a question or I state an answer that is wrong to the question the professor is asking. But a lot of times I know the real answer if I just sit and think about it, but I want my brain to like instantly know the answer. And I think sort of like sometimes your brain needs that feedback from, the professor, whoever it is that you just answer the question to.
Yeah, timely feedback.
That like, oh no, that's wrong. So make sure that the next time that question comes up, you know the answer to it. Yeah. And so, I don't know where I got that from, but I was just like, even if I know I'm wrong, or maybe I won't know I'm wrong at first, but whenever I shout out the answer, I'm like, oh, that doesn't even sound right. But I get that feedback from the professor saying, hey, no, that's wrong. It's actually this. I'm like, okay, it's one more time that I've been actually able to hear the real answer. right?
You actually get it.
Yeah, I think sometimes it's just a lot of times studying and learning something,
Yeah.
you need repetition.
Oh yeah, yeah.
Right?
Sometimes you just need it to give it time to sink in.
Yes,
Yeah.
exactly.
I think this next one is the most interesting.
Okay.
Is it a body of presiding study scientific or merely academic? Now that's interesting. I think that's an interesting question.
Merely
Is it? Yeah.
Go ahead.
I feel like. So what it's asking is it just is that study using the scientific method itself, which it gets kind of meta, right? Because we're talking about the scientific.
Yeah.
But or is it just academic in the sense that does it base itself on like just purely heuristics, statistical, or like is it a more of a theoretical framework? You know, like, or is it actually scientific based on empirical and like you know?
Yeah, it almost sounds like did you use the scientific method or not?
Yeah. Because every time people say study, they will think academic study.
Yeah.
And people oftentimes use scientific and academic interchangeably.
Wait. So then what is the difference?
Academic, that's my point. That's why this one's so interesting.
Okay.
When it wrote down, like,
So do we know the difference between academic?
I feel like academic studies more institutional, like you have to do it. But I feel like scientific study is more like
I'm gonna ask ChatGPT because I don't. This is interesting.
meta study is still an academic study and it's not pinnacle of scientific rigor, especially if meta study is employed as an excuse to avoid having real scientific study. That's crazy. Oh no! Actually, it gives it gives the differentiation between academic and
Oh, it does.
yeah.
Oh, just scroll down further, huh?
Yeah, no, yeah. Just scroll down further.
Okay, so let's see here if there's like a key difference is all science is academic, but not all academic work
Is
is scientific. Scientific
That makes sense.
Scientific equals uses the scientific method. Academic equals any disciplined scholarly work which might or might not be scientific. Oh, so like maybe like writing a paper on the state of the world or something like that.
That's academic. Yeah, that
Yeah.
makes sense. But is it science?
I mean, if you didn't use the scientific method while writing it, then no, right?
No, but that gets a bit meta, right? How do you're in a weird way circularly arguing, because it's like we're talking about the scientific method, but one of the criteria of scientific method, it has to be scientific.
Dum dum dum. All right. Well, anyways, yeah, let's move on.
Okay.
And so the second part of this is intelligence, and so that's the second part of plurality, right? And so.
Is there structure or patterning to the domain observation and data?
Yeah,
Well,
so
I guess it's just looking for patterns and correlations and whatnot.
yeah, I mean that makes sense.
Yeah.
I mean, of course so intelligence meaning the data, right? And so yeah, does that data hold any patterns or structure, right? I mean that's essentially what we're looking for, right? We're trying to find the thing that repeats itself. So then that we can say like there is some there's something that can be replicatable then. Possibly.
Repeatable, replicatable, or just anything that you can see as correlated. This happens and that happens at the same time, or that happens right after that thing, you know?
For sure.
Or have key observations been dismissed as claims? I think that's interesting as well.
As observations have been dismissed as claims. So yeah, a claim meaning it's not necessarily have like proof, right? It's just something that someone said.
Secondary
information. Yes.
Like oh well, I'm not gonna listen to you because it's been disproved. You know, like that type of thing. Like
okay, and so does the presence of agency exist? Oh, like what do you mean? Like exist in what? presence of agency exist, right? Because it looks like we can basically click on each one of these links. And so let's just be transparent here. So
We're using a website called the Ethical Skeptic.
and so from what I have heard is he is very thorough
with the definition.
with definitions, and he's, I want to say, one thing that is weird, that I think is weird about him, is we don't actually know who the ethical skeptic is, yet he publishes this information, but it does have a lot of weight to it. It's actually really good information. Because if we were to just look up, let's say, for instance, the scientific method, right? And I'm just going to basically Google it and look at the images.
So, So agency, by the way, I just figured out, is whether an information is an activated or intentional or methodological form of bias. So is it like a propaganda, or is it like for example, is it a company trying to promote its own product? Or is it a genuine study trying to prove whether that product's dangerous or not?
Okay. Yeah, so, yeah, I wanted to sort of take a second. So if you just Google the scientific method and you look at the images, right? Typically, it's a very, I want to say, like, to the point, like 1, 2, 3, 4, 5, 6, 7 different columns here, right?
Yeah.
But if you were to just take this and run with it, I don't think that's enough information. So, for instance, the scientific method, observation/question, and then it says topic for research and experimentation, or question that needs to be answered, right? And then, okay, you go, and then it says research, find out about the topic. Then you form a hypothesis, predict the outcome to the problem. Experiment, develop a procedure to test the hypothesis. Then collect data, record the results of the experiment. Then you have analysis, examine the data. And then the conclusion, compare the hypothesis to the experiment's results. And
I mean, that's pretty standard.
yes, exactly. But at the same time, like, don't you want to know what each one of those steps entails so that you can, I don't know, be better at applying the scientific method?
I think the right word is, don't we want to be more thorough with it, right?
For sure. And that's why I love this
definition,
ethical skeptics definitions, or definition of the scientific method, because it's extremely thorough. Right. And it makes you ask questions like we're doing right now that you wouldn't have thought about. Because some of these questions I'm like, wait, what? And so yeah, that's why I wanted to bring this up. So then what do we have? Let's see here. Does the presence of agency exist? We went over that. Does a state of Chekhov's gun exist? What is Chekhov's gun? Okay, so let's see here.
Look into
4 indicators of a personal ethical objectivity. Oh my gosh, and it's like a full
a Chekhov's gun. A dramatic principle that states that every element in a fictional story must be necessary to support the plot or moral. An irrelevant element should be excluded. It is used as a part of a method of detecting lies and propaganda. In a fictional story, every detail or datum is supportive of and accounted for as to its backing of its primary agenda and idea. A storyteller will account in advance for every loose end or ugly underbelly of his moral message, all bundled up and explained nicely. No exceptions or tail conditions will be acknowledged. They are not part of the story. Oh, so are they hiding anything, basically?
Okay. Interesting.
Basically, are they buttering it up? Are they like sugarcoating it?
Okay. So we're making sure that the data isn't sugar-coated? Is that what we're saying? Or nothing being hidden in the data? Or
it's not. Yeah.
Man, some of these words in this are insane. Does a state of amplenecdote exist?
I have no idea what it is.
What?
I know anecdote. What's an amplenecdote?
I have no clue.
We're learning something new every day, guys.
Yes,
That's the whole
yes.
point of research, right? Look into something you don't know.
Exactly.
But amplenecdote.
What does this mean?
Amplenecdote. Anecdote, bro.
I have no clue. I'm about to find out though. Okay, so the phrase looks like it comes from the Ethical Skeptic, of course. Thank you, ChatGPT. Anecdote. So an anecdote, a single story or observation, often dismissed in science as just anecdotal, right? So it's like just because something happened to you doesn't necessarily mean
It happens to everyone.
exactly. And then amplenecdote. Oh,
me.
bless you.
I'm allergic to new words.
A coined word by the Ethical Skeptic. Okay, so it's a new word he made up.
Yeah, yep, he pulled it out somewhere.
Meaning a large collection of consistent anecdotes that, while individually weak, collectively suggest there might be a real phenomenon worth investigating. Okay.
Okay. Here's what I'm thinking. Do you know how? Okay, this is a slight tangent.
Okay.
So let me bring up a. I don't want to call it pseudoscientific, but it is kind of pseudoscientific. Tarot cards.
Okay, yeah.
So people for tarot card.
Tell your future.
Yeah. So for people out there who like who are tarot card fans, no offense, this is just a scientific discussion. But basically, what I'm thinking, why people love tarot cards so much and even like horoscopes, is because they're vague. And they're vague. For example, let's say I pull out a few cards and I point to something vague about your life. Like let's say, oh, it's something related to your relations. And then the tarot card reader will ask you, is there anything in your personal life regarding any relationship that's going on? Then you start thinking about it. Because you believe in the tarot cards, you introspect further and you start bringing up real problems to back up the tarot cards. You're helping the tarot cards find information. The tarot cards are not finding information, you are. Does that make sense?
Yeah.
I feel like it's sort of like the coin flip thing. In psychology, basically, they said that if you want to know your true want of a decision, like let's say you want to go to this restaurant or that restaurant, right? You don't know which one you want to go, but if you do a coin flip, and then it landed on something, let's say you don't want, right? You will notice, I don't really want that. Then you know your true intent, right? I feel like it's sort of thing that tarot card does. It sort of tells you what you needed to hear, so that at least what the tarot card reader tells you, what you needed to hear, so that you bring out the information that they can work with. Does that make sense?
Interesting. Yeah.
So I feel like so I feel like people believe that, oh, the tarot card works. I feel like what it's trying to say is, yes, it works, but it's probably not the way you think it works. You know, it works. It doesn't work in some mystical, supernatural way. It's just sort of psychological. It's more, you know.
Yeah, I mean, so
Even though anecdotally, individually, people who have worked with tarot cards, that it works, it solves so many problems. No, it didn't. You probably solved the problem yourself. It's just that the cards help you ask better questions.
Okay. Yeah, so I was thinking a little bit different about it. So I was thinking, let's say, here's an example, UFO sightings, right? So whenever, let's say, when people first saw UFOs, right?
Aliens.
Yeah. So the first person seeing it and going and telling someone, you're not going to think anything, right? You're going to think, oh, this is anecdotal, right? And you're just going to dismiss it, right? And so, but what if, like, you start to hear a bunch of people?
I mean, mass hysteria is a thing too, though.
Very true. But, and so let's say you have a bunch of people, but not only from like the same area, but let's say across the world, that have seen UFOs. Well, I think what this is trying to say is then that's when it can sound anecdotal if you only listen to one person, but once you listen to a bunch of other people that have had this same experience, then
It's
that
something
is
worth looking into.
yeah, exactly.
No, exactly. That's the same with the tarot card thing. So
Okay.
like, because a lot of people are into tarot cards and horoscopes, right?
Yeah.
But I feel like, although on their own, it's probably not scientific, but I feel like there is a scientific phenomenon that's making them
Okay.
like it or believe
Yeah, yeah,
it.
yeah,
You know what I'm
yeah.
saying?
All right. Yeah, no,
Yeah,
that makes sense.
yeah.
I guess
That's why.
didn't get what you were saying at first. But yeah, I see what you're saying. Cool. So let's see what else. The last one on intelligence is how can I creatively frame and reduce the data set into intelligence and simply data?
I think the right way to frame this is, the hierarchy of wisdom. Wisdom, knowledge, information, data.
Yeah.
Data is just pure numbers that you collect from around you, like pure observational data.
Yeah.
Then you plot in a graph and you see correlations and patterns. That correlation is information. It's still not causation yet. It's still not like knowledge of something, what's going to cause what. It's still just something's there. That's why it's information. That knowledge tells you is when you start deducing, this caused this. That's knowledge. You know the solid causation of the system. Then wisdom is you use this knowledge to do something practical. I think what this guy means is how do you turn the data into information?
Yeah, something
Useful.
Yeah, exactly. Yeah. Yeah, I mean that's a lot of my work with machine learning, right? We get a lot of graphs to then analyze the data. And a lot of the graphs don't really make a whole lot of sense, right? But there are some certain graphs, let's say like PCA, which is principal component analysis, right? Which is essentially if you have a high dimensional data set, right? So high dimensional data set, meaning let's say you have, let's say you have a person, right? So you have their name, and then let's say you take a bunch of like data sets from them, like their height, weight. Yes, exactly. Height, weight, right? And so if you just take their height and weight, and then you just take get a bunch of those data points from different people, right? That's sort of a low dimensional data, right? Unless you have like a million people, right? But then, but then what if you take more characteristics of the person, right? Or what if you start taking their blood samples or maybe their DNA, right?
Yes.
So that is going to become a very high dimensional set of data. And then you want to know, okay, well, let's say you want to know, I don't know, let's say whether the person may get cancer down the line, right? And so you want to figure out which features,
Which dimension? Okay, before we continue, sorry to cut you off. Whenever a scientist, engineer, or mathematician talks about dimension or space, we're usually talking about if you can use any quantitative or qualitative information to put it in a line or an axis. If you can use, for example, like what he said, height, you put it in one axis, weight, you put it in another axis, or hair color, you put it in another axis. That is what we mean by a dimension. Each axis is a dimension. And when you have enough dimensions, you create a sample space or subspace or a space of information where the data points can exist. That's what we mean by space and dimension. We're not talking about some high mythical dimension or anything. So anyways, keep going.
So yeah, PCA, and so what PCA does is then it tries to find the features that are best suited to predict for, let's say, cancer, right? And so it does this by sort of reducing the dimensionality in the data, right? And so PCA can be a really good tool to sort of find the patterns in the data, right? And then to also find the best features for predicting something like cancer, right? And so yeah, that's just now. But PCA is not always the best way to go.
Best way to plot data or find correlations.
Yes, or maybe there's some other tool to reduce dimensionality that would give you more fruitful graphs to look at and to use that support your hypothesis, right? And so yeah. And then
I
so
feel like someday the next topic we could talk about statistical mechanics.
Oh,
and
that'd
the
be
curse
fun.
of dimensionality.
for
Oh
sure.
yeah, I think that'll be fun.
Yes. Yeah, I've watched a lot of videos on that.
Yeah. I think that'll be a fun topic because that's
it's-
that right down our alley.
It's a beautiful topic. I mean, to think of that. Let's not do it. Anyways,
We'll do this. Yeah.
necessity. So here, now we're going into the third tier of plurality, and so so the third tier is necessity, establishment of necessity. So like we talked about earlier, why this thing is needed for the world, why the world needs.
Why do we even ask this
Why do we care?
Yeah.
Right. So the first thing is, if we were wrong on this topic, would we even know it?
Is it falsifiable?
I love that.
I think is it falsifiable?
I love
I think
that.
that's the right word.
Because
Yep.
yeah, I mean, yeah, how do we know we're wrong? I think about this. This is the sort of thing that keeps me up at night, right? It's like, okay, I've done, I've taken the data, I've done the machine learning on it, and I've gotten the graphs, but are these graphs actually true to
Are
the
they
data?
consequential? Do they actually give us a causal, like, can we infer a causal relationship in there?
Yes. And so I'm always worried that, well, maybe some guy comes away, and me and Predator were talking about this the other day, but like, you've worked so hard on this thing and you want it to be right, but somebody could maybe easily come in and say, oh, well, did you first,
Figure this part out.
that, or did you, like, in data, right, there's like certain things that you need to do, like when you're doing a data analysis, or like
Pre-processing.
pre-processing. Exactly, there's a lot of things you need to do to the data before you can even start to analyze the data, because if you don't do that stuff, then the stuff you have at the end is all just mumbo jumbo.
Yeah, too much noise.
Exactly.
But I think this goes into I think this goes into a broader topic, epistemology. Epistemology.
Like, what do you know?
How do we know what we know? The study of knowledge in philosophy. But we'll get into that after.
Well, and then how do you know it's necessary, right? How do you know that what you are? I mean, to me, right? I think it's very necessary to find new materials, but maybe not everybody thinks that way.
I mean, for example, I always use this analogy. I even give it in the talk, in the lecture, is that when Einstein and a lot of other scientists back in the day, when they discovered the photoelectric effect, they did not think, oh, we're gonna use this to create laser eye surgery in the future, or making barcode scanners in a supermarket. They never thought of those things, or laser pointers that you used to point in the sky, or screens. They discovered a phenomenon. Engineers down the line figure out how to make this useful.
Yeah.
But when we first discover something new or question a new idea, usually on hindsight, it's useless.
Yeah, I wonder if, like, the guy who came up with the Monte Carlo simulations, if he knew that, well, if he knew, well, he definitely didn't know the power of it, but I'm wondering if he had an idea of that, oh, this could be used for nuclear physics.
I don't know, maybe.
Right, and building a nuclear bomb.
Right. That is true. Wait, didn't he? Yeah. They used his Monte Carlo simulations to and the Markov chain and whatnot to
Exactly, to help
predict.
build the because
build a model of the nuclear fission.
Yeah, exactly, to build the nuclear bomb, the first nuclear bomb. But anyways, so the next one, if we were wrong on this topic, would this be enabling harm to stakeholders, especially those who are innocent? Yeah,
Yeah, that makes sense.
yeah, like
Back in the day, the radioactive makeup.
Oh,
do you remember that?
Yeah, or they used to put lead in everything.
Yeah.
But
Because they didn't know.
well, I don't know, because lead has been, like, I think the Greeks knew that lead was bad, right? I believe people hundreds of thousands of years ago knew that arsenic was bad, but we've put those things into all kinds of stuff, like just in the 1900s.
I feel like
consumables, you know?
yeah, I feel like it's more of because yes, back in the day, a lot of people know about it, but does everyone know about it? I feel like yes, people back in the day know about it, but I would think it's mostly scholars, nobles, or like people who are working in that craft. I
Yeah,
don't
but
think
if
normal laymen would
if you're
know.
building the thing, right?
Yeah, yeah,
If you're
yeah.
built whatever, and let's say you're using lead, right? And let's say you're using it as sort of a
Pipes.
liner. Yeah, exactly. You would think that that person doing that would know how bad lead is for people, right?
I think what they didn't know was that lead would leach. I think they know lead in the water would kill people, but
Yeah.
I don't think that they did know the solid metal
Yeah.
lead pipes would leach into the
Yeah,
water.
no,
I think that's what
that's
they
a
didn't
good point. So, a really good show that I've been
Yeah.
watching lately is called The Terror. It is so good. dude.
Terror.
It
Oh,
is
I need to look into
so
that one.
good. It's on Amazon Prime,
Oh.
and so the first season is they're on this boat. There's two seasons, but they're like two different stories. So the first season is, and I swear I'm gonna get to the lead part.
Okay. I believe you.
Yeah. But I've got to talk about this show because it's so good. And so the terror, and so there's these guys, the Marines,
Yep.
and they're explorers.
Yep.
And so I believe it's the British Empire. They spend the money on, and I guess were for a long time putting a lot of effort into finding a route through the North Pole over to America, or on the other side of America into China. And because they felt like being able to do this would
Save time.
save a lot of time, right? And so the terror is sort of based around like they've got like this ship that, or two ships, right? And they send them off, and they're trying to find this passage through the North Pole. But one of the captains, or the second captain, right? Or I don't know what you would call him, but the number two
Vice
from the captain, yeah, vice captain. He is like warning them, like, hey, we shouldn't go any further. Like, they have to go and break the ice. So like there's like a scene where they're literally like, the ship can no longer break the ice by just hitting it. They
have to dig.
They have to like put dynamite into the ice and break it up that way. Well, they get so far into this that they actually become one with the ice, and so they're stuck out there, dude.
Oh yeah. So the water freezes faster than they can break it.
Yeah, and there's like nobody out there other than like Inuit or Eskimos.
Yes, yes.
Right? And so they're out there for a long time. They're out there for years. Years. Yeah. And so, and what's crazy, they have like enough provisions for this, which I'm just like, yeah, how do you have enough food to, because they had enough food for I think 5 years is what they said. But so back to the lead.
Maybe if they ration it, yeah.
So they're water tanks, right?
Yeah.
Apparently they were made out of lead, or lined with lead.
Yeah.
And there's a scene in the show that talks about like lead poisoning, and because so there's a couple of doctors in the show, and one of them is like, hey, have you noticed? So each boat has a doctor, and one of the doctors goes to the other one and is like, hey, have you seen anything with like people's gums and teeth like having this weird color on them? He's like, I think it's like lead poisoning. And he was like, well, we have lead in our water barrels, but, as far as we know, it doesn't actually leach into the water.
As far as we know.
Yeah, exactly.
Yeah, okay,
exactly.
I see. That's a nice way to tie back into it. That's crazy.
Yeah. So what's the next one?
Has harm or ignorance now surpassed a critical point of reflection? So I would think that has a certain idea that is wrong or not knowing something reached a point where we don't care about it anymore, or at least to a point where it's hard to change it now. Something that is taken as, oh, it's just another day.
Yeah, these sort of seem like questions you would ask yourself if you're trying to make sure that you're like really doing the right thing.
Intellectually honest, I think.
Yeah, and a lot of these the necessity questions are like, are you going to create harm? You know, it seems like there's like some moral dilemma in this.
Yeah. I mean, that's the ethics behind science, right?
For sure.
If you get something wrong, you might fuck some. By my French, you might like hurt somebody. You know.
Well, it's funny. I've set this podcast to explicit. But I don't want to cuss, right?
Yeah.
I know some people can be a little offended from cussing, so
Yeah, I'm trying to tone
and
that
then
down too.
I also wanted to be more of an educational
More
thing.
professional and more formal.
Yeah. But if it slips, it slips.
Yeah,
no worries.
it's my bad,
No worries.
All right, but
So actually, I want to go back to that last one though, because I feel
which
like
one does the harm
the
or
enabling harm to stakeholders, especially those who are innocent, because I think humans are always trying to push the boundaries, and what I mean by this is like let's see, I think it was like in the 50s. Yeah, in the 50s. So there was a lot of, and even before that, like when the industrial age started to just like get hammering, right? Like, so there's like big bellowing what do you call those things? Polluting stacks like everywhere now, right? Because there's these big manufacturing facilities like everywhere, and we're really gung ho about it, right? Because it's creating jobs, it's helping build our economy, but they weren't thinking about the human element though, because they weren't
the consequences.
And I'm not saying that it's their fault or whatever. There's totally there's documentaries that would say yes or no to that.
Yep.
I don't want to be the judge on that, right? But these cities that they had like these big industrial manufacturers in them were having smog issues, and people were like dying from
Yes, especially in the dawn of and advent of the Industrial Revolution, people because the population of London started like skyrocketing, but the number of people dying from like the pollution is also like spiking.
Yes, yeah, for sure.
And I also want to mention a good movie called Dark Waters.
It's just funny. I want to mention this movie.
Yeah. Mark Ruffalo.
Mark Ruffalo?
The guy that starred Hulk. The Hulk.
Okay, yeah.
Yeah, so this movie is just basically about it's a true story based on an attorney named Rob Billets, I think. I don't know butcher his name, but basically he exposes DuPont, the one that makes the forever chemicals, the Teflon and whatnot, for the chemical byproducts that
PCBs or whatever.
PFOAs.
Oh, okay.
Yeah, but basically it's just a Teflon precursor that it causes a lot of harm. So I really recommend people to watch it. It's pretty interesting how this is where ethics comes in. Ethics is important when it comes into research.
Yeah, we've created a lot of things,
and we didn't know if they can cause harm. And some of them willingly hide.
Yeah, I mean, a lot of things also have gone out that they knew were harmful.
So the
I don't know. Like I said, I don't want to be the judge, but but I think that's why it's good we're talking about this stuff, right? Is that for me,
science go hand in hand with ethics.
Exactly. I want to create ethical products, right? And so yeah, whenever I go to pick a job, I'm gonna make sure that the company has the same sort of morals that I do, right?
That makes sense.
And so let's see, next one. Do existing explanations feature elements of pseudo theory?
Pseudo theory.
Yeah, so kind of like the
yeah. Okay, that makes sense.
Yeah, is it sort of pseudoscientific?
Yeah,
is it
pseudoscientific.
Yeah, you don't want to try to build on top of pseudoscience, right?
So I think it's pseudo theory. A good way to put it is a self-consistent story that does not actually reflect in reality. So,
yeah.
Is there another necessary alternative?
Necessary alternative.
I mean, for example, like in quantum mechanics, we have the pilot wave interpretation, the Copenhagen interpretation, the many worlds interpretation. We have these alternatives.
Huh. I mean, but that doesn't, I don't think that answers. I mean, is there another necessary
So where?
alternative?
But what? So how would they?
Yeah, what is a necessary alternative? I mean, I kind of get what it's saying, but
I mean, for example, Newton's law of gravity is already pretty good for its time, but Einstein gave a alternative that still is way more accurate and is way more useful in the modern day's perspective. But we still use Newtonian gravity for simple cases. You get what I mean? So they're both alternatives of each other. One is more necessary in one case than the other. You know?
okay, so is it like saying, well, don't try to, build something or make something or come up with some model
That we don't
that can already
have.
be explained or whatever. Okay. Okay, so is another alternative necessarily compelling?
Yeah, it's like Einstein's theory of relativity and law of gravity. Can simplicity no longer be claimed to exist?
Simplicity no longer be claimed. I don't know if this is necessarily what they're talking about, but I do hear a lot of times.
I think it's Occam's razor.
Okay. I think maybe what I'm about to say is sort of related to that.
Oh.
But so I hear a lot of times that the most simple path is sometimes the best path. Right? And so why make things over complex if you don't need to? Right? If we already have something that does it simply, why?
It's like Maxwell's equation, right? At first it started with 20, it ends up with 4 because of Heaviside. So he made it more simpler.
Yeah.
And it still works. So that means there are other elements that we do not need.
Getcha. So if you're going to try to, or if what you're doing makes something more simple, go ahead with it. If not, then maybe you should
stay there. Yeah.
Yeah.
Can it be simpler is the question. Yeah.
Does a state of necessary ethical action exist?
Oh, I think this is purely about ethics now.
Yeah.
Does a state of necessary ethical action exist? I think this goes into the idea of the atomic bomb. Let's say you have the knowledge, you have the discovery, but is there any regulations that you need to put in place?
Sorry, ethical action.
Everyone
I don't know. I still go ahead. Yeah, I just want to reiterate, we're not experts. We are trying to be, and so I think that's sort of what we wanted to make this. It's sort of a thing that we pick a topic and we work through it.
Yes. This whole our whole framework, or at least our whole idea of Jupiter Brain, is that we want to make it as casual, as transparent, and as real as possible. What we don't know, we'll learn along the way. What we know, we'll just say what we know. And if there's anything we said wrong, please point it out. That'll be very appreciated.
Yeah, I've gotten a lot of feedback already, and I love it. I try not to think about it, right? I try not to think about like other people listening to this, because for me, I just wanted a place where we could come and nerd out. Yes. But I love that people are already watching it, already have like some feedback. We love feedback. So it says, a state of necessary ethical action is a situation where ethics demand you act, where inaction itself becomes unethical. So an example of this is in medical ethics, a doctor must provide care in an emergency. It's not optional.
Must.
Yeah. And so here's another research ethics. If an experiment shows harmful side effects, the researcher must report it. Yes.
DuPont.
We just talked about that. Yeah. Yeah, I try not to go. I don't know. I don't want to throw any shade on anybody, right?
No, I'm talking about a movie.
No,
That's
yeah,
what- yeah, yeah.
I know what you mean.
Yeah.
But like, there's so many examples of where
Research could be skewed.
yes, or I've seen where people hired other researchers to sort of put down claims of others because those claims are showing that
They are better than the others.
either that or that the product that these other people are making is bad for
Yes,
people.
yes.
That happened in the situation I was talking about earlier with the smog. Is there was a scientist that published something that talked about how gas emissions were also adding to the pollution in the air that was harming people. And so the petroleum companies got together and found researchers that actually put down his research, showed that, oh well, his research wasn't thorough enough. His research is wrong. Petroleum's not bad for anybody. Which I think oil is necessary,
But
but it can be harmful, right? But
we need to be realistic about it. Like, like fusion, not fusion, fission, nuclear fission is very useful for generating energy, but the radioactive products is still a big problem.
Yeah.
I feel like we need to face the problem alongside its advantages. you know?
I think we just need to be okay with being more honest with each other.
Yeah.
And being okay with the fact that, okay, yeah, this thing can cause harm, but is it overall better for the greater good?
Yes.
Like my thoughts on energy are that, yes, we should use oil and gas, but we should also have alternatives,
Yes.
right? So, I don't think gas will ever be phased out, maybe, right? But my thoughts are I think it's better if we use all of our resources that we have in an even way, and then maybe we find out that this resource is actually better, right? But we're never going to do that, and we're going to find that out if we don't explore those options.
For example, Teflon is a very important thing in medical labs, in equipment, in even everyday life. And yes, we know it has side effects if the byproducts are treated or just poured in nature. But if they manage it well, honestly, there isn't a problem.
Yeah.
Yeah, I really think it's more of management.
Yeah.
No.
Yeah, I mean, there's things coming out all the time that talk about why this thing is bad for us now, why that thing's actually good for us now, why, like for instance, cholesterol. Cholesterol's a weird one. Apparently, they used to say that cholesterol was bad for us, but now some people say it's good for us, and it's like
Well, I think it's more nuanced.
Yeah, for sure. Yeah, and but that's what's kind of crazy is let's say you go on the news and you talk about your research or whatever, you can't really talk about the nuances, right? You have a 2-minute time frame to say what it is, the gist.
I think that's the thing. The blind spot of information is the problem.
Yeah.
It's not that people I feel like yes, sometimes people lie by omission, but I feel like sometimes it's more like they don't have time.
Yeah.
So that's why they accidentally leave out something that's important.
Well, that's why I love podcasts, right? Because there's time to navigate through the nuances. And, I think that's why it's important to have big reseachers and very influential people go and talk about the things they care about on a podcast and talk about why they care about those things and be nuanced about it, so so that we can make sure that there's no
I feel like I think
they only have the devil on their shoulder. Anyways, so the next one, construct formulation by sponsors. It's in parentheses. I don't really know.
I feel like I just scrolled through. There's quite a lot. Do you want to
Yeah, there is.
fly through them instead? Because I feel like we're lingering a bit too much on the first. We just barely got to the fourth one.
Maybe we could just do 2 from each one.
Yeah, sure.
Yeah.
Do two from each
Let's
one.
let's
I
do
think
that.
that's the best. Like we just look for the most interesting one out of the.
That sounds good. That's fine. I mean, what, we are only an hour and 32 minutes in.
But we have to talk about other stuff.
Oh, we do. What do we have to talk about?
Epistemology.
Okay. All right.
Yeah.
Yeah. Let's get it. Go ahead.
So right now we're in construct formalism part, right?
Mm-hmm.
Okay. So what other placeholder ideas or constructs can be established? We could theoretically solve this problem. How can this idea construct or Wittgenstein defined? What is the Wittgenstein defined?
Wittgenstein. How can this idea be constructed in a Wittgenstein-defined, rigorously logical form and be interrelated with prior art crafting? I don't know. It sounds like some way to to rigorously back up your claim, right? Let's see here. What is Wittgenstein defined? You have a thought of that?
Give me a second.
Do you have homework? You probably have a lot of homework.
Yeah, but yeah, I'll handle it. I'll handle it.
No, I'm not. I'm just trying to kill the dead air.
Oh yeah, that's true.
It's just I get nervous when there's like dead air. But anyways,
I mean that's where we have editing.
yeah. So
Domain of comprehensibility.
mhm.
So, is it graspable by the human mind? And then second is descriptive symbology. Can it be described by symbolism, both privately or commonly? And that intelligibility, is it a framework that can be used to reference previous foundational knowledge? Oh, so I think the main part is just, can it tie back to old knowledge? I think that's probably what he means.
Oh, okay. So it aligns with things that have been found before. Is that what you're saying?
Yeah. But this six tenets is the most important part: comprehensibility, descriptive symbology, intelligibility, observability, tolerability, and sustainability. The six characteristics.
I just asked ChatGPT to sum this up, right?
Yeah.
This whole section. It says this stage is about moving from raw observations and scattered ideas into a workable conceptual model that could theoretically explain or resolve the issue at hand. Okay, so this is the model forming. So yeah, like I said, it's sort of the logical formalism of your idea. So
does it satisfy those six ideas? So how can this idea be expressed in such a way that practitioners can understand and teach it? Well, that one, it's pretty straightforward. Can you teach it without leaving out the nuances? Are sponsors being unfairly quashed or individually targeted by agency players claiming to represent science? Oh, whistleblowers and stuff. No?
But it says unfairly, like whistleblowers.
Yeah, they get targeted unfairly.
Oh, okay.
Occam's razor. I think this is a very important part.
Okay, so yeah, let's go on to the next one.
Yes.
So the last one was basically forming a model for your
for that explanation, that phenomenon. Occam's razor. So for people who don't know what's Occam's razor, which we just explained, which is the simplest path to a conclusion is often the most correct one. That's what Occam proposes.
Yeah, which I don't know. I kind of have a gripe with that. Because, I mean...
I feel like it could be fallacious if it's overdone, oversimplifying a model.
Yeah.
But I feel like it's a good guideline to prevent yourself from over-constructing a model.
Do you feel like that's anthropomorphism at all?
No.
Like... because, like, for instance, simplicity to me sounds like beautiful. We like a thing because it has a certain characteristic, and a characteristic is simple, or the characteristic we're talking about right now is simplicity. And so just because it's simple, right? Like, for instance, the answer to the universe, right, is 42.
Oh,
right?
yeah. I think the right way to put it,
Mhm.
I think the right way for Occam's razor, like, is that how many things do you actually need to explain this phenomenon? Do you really need more than that? Like I said, the Maxwell equations, you have 20, but Heaviside made it to 4. Do you actually need 20 equations to describe electromagnetism, or do you just need 4? Or, for example, flat earthers say that the earth is flat and the sun's like going like right here, and then the stars are in like what they call it, domes. Like, these are unnecessary explanations to a model that we already proved.
Yeah. Well, but I think
Overly complicated things. Epicycles. Epicycles, they predict accurately how the stars and planets move through the sky.
explain epicycles.
Oh, my bad. Epicycles basically is back in the day when we used the what's it called, geocentric model, where the Earth is in the center of the solar system. So, astronomers needed ways to explain the weird movements of stars and planets in the sky. For example, like Mars and Venus, when they orbit, it's not like they just move across the sky. They move like this, back and forth, back and forth, back and forth. And the reason for that is because, well, obviously, all the celestial bodies orbiting around the sun, not around the Earth. So it looks like they're wobbling back and forth around us, but they're actually going around the sun. So to explain that, they use epicycles, and mathematically, epicycles actually work. It does explain what the behaviors are, but ontologically and epistemologically, like, what's it called? It's not the most simplest explanation. It's not the most epistemologically elegant way of explaining. But once Galileo tried to propose the heliocentric model, the epicycles weren't even needed. It wasn't even needed to explain how the celestial bodies move through the sky. You see what I mean?
Yeah.
So when you have a better model, Occam's razor naturally removed the need of epicycles because the sun's in the center, everything's just going circularly around the sun. But without that model, we use Earth in the center. It looks like everything's moving back and forth, and we need epicycles to explain, and that's unnecessary.
Yeah, I think though that there are some things that need a complex.
But how? I know, but like, how much? How complex do you need is the question I think Occam's trying to point to. Like, do you actually need that much complexity to explain one system, or is there a better and simpler way to explain it?
Oh, okay.
Yeah.
I see. So, yeah, like you don't. Okay, I see what you're saying.
Yeah.
I just don't have a good way of. Okay. Anyways, next one. So the next one is what? Are we going to move on to hypothesis?
Yeah,
development?
I guess we can go on to that.
Or wait.
Okay. Actually, I think one important part
Okay.
is plurality now necessary. I think we need to talk about that.
Is plurality now necessary? Okay, so what to you is plurality?
From what I understand is, do we need many different perspectives on one thing?
Well,
So multiple different explanations for one phenomenon. For example, some people say the sun's orbiting the Earth. Some people say the sun god Ra is dragging the sun across the sky. Do we need so many different perspectives of one phenomenon?
I don't know. What do you think?
I think it's not. I feel like it's a rich part of human culture, but I don't think it's necessary. I mean, it comes back down to how we define necessity.
Okay, so it's instead of sticking to one dominant accepted answer,
There are multiple
there's
answers.
multiple competing explanations.
Like, Earth is flat and Earth versus Earth is globe,
Interesting. I don't know. I mean, it's to me. I don't know. Yeah, like for instance, you could describe some phenomenon with chemistry, or you could describe it with physics
Or biology.
or biology, right? And I think depending on the person, maybe it depends on which explanation they go to, and maybe they sort of relate with the most. I don't know. Like,
I mean, for example, using different tools to investigate or describe a phenomenon is not the same as describing the phenomenon differently. You know what I'm saying? For example, we use you could describe a biological system with purely quantum mechanics, but that's unnecessarily tedious. But it's better to use chemistry, biochemistry, and biology,
Yeah.
which is more straightforward but correct. But what plurality is explaining is, instead of using chemistry and biology to explain how the body works, you use chi, the energy going through the body, you know, like, or like Star Wars people, the midichlorians.
you don't like chi, dude?
I mean, I fight with it, but like, I mean, is it true? I don't know, but like,
Yeah.
as far as I know, I don't feel any chi going through my body. You know what I'm saying? Just ATP.
It's just ATP.
Yeah.
That's hilarious. I don't know. You know, I mean, is chi sort of like consciousness? Is that
So it depends who you ask, because
sort of
so
the
chi can translate into energy, force, air, or breath.
okay?
So, but the traditional way is trying to say, like, at least in the pop culture description of chi, is like the vitality, the life force in you. You know what I'm saying?
Interesting.
It's in everything that's alive. At least in
no.
traditional medicine.
Yeah, I mean, I'm all for whatever like helps people get through the day.
Yeah, but
I'm sorry. Yeah.
yeah, I agree, but I feel like as long as that model, they don't stick to that model just because it's convenient.
Yeah.
I feel like people should always try to strive for a more accurate and ethical model.
Yeah. I think that's why we're researchers,
Yeah,
scientists,
true,
engineers
true.
is interesting.
Yeah.
Okay.
Okay. Now we go into cultivating? No, hypothesis development.
Ooh, wait a second though. So this is interesting. If plurality is necessary, it means the evidence suggests we don't yet have a single complete explanation.
Yes. And if plurality is ignored, it can lead to like propaganda and dogma.
Okay.
Right?
Yeah. It's funny. ChatGPT uses the exact same
Words?
The example you gave about ellipses or
Epicycles?
epicycles.
Oh, really?
Yeah, it's hilarious.
My nickname is ChatGPT for a reason.
Oh, for real?
Yeah.
That's
Ever
what's
since
up.
high school and in college, people call me Encyclopedia,
Yeah.
Google,
Yeah.
or ChatGPT.
Dude, yeah, you are definitely a wealth of knowledge.
Thank you. I
For
appreciate
sure. I learn something new every time we hang out.
that. Yeah, I appreciate it. I learn a lot from you too. So.
Cool. Okay, so we moved on to hypothesis.
Yes.
Okay.
Hypothesis development.
Okay, so this is a big one, right? Like, what's funny is this is like a big one, but it's like two questions.
It's the tiniest one, but I think it matters the most.
Yeah, because you want to like what it says.
Okay. Actually, I feel like all of the previous parts can be tied into. You know how just now you showed that that's just 7 categories.
Yeah.
Like hypothesis is the first one. I feel like this is all ties into that one category.
Into hypothesis?
Yeah.
Really?
Or for the previous one that you showed, you know what I mean? Everything that we just talked about ties into observation and questioning.
Oh, yes.
Right?
Like the things you need to be thinking about before you make your hypothesis.
That's why it says hypothesis/question in that first category, right? The first picture you showed me just now. No. I mean, like
the
other
Google one?
Yeah, the Google one.
Yeah.
The traditional.
Yeah. But
I feel like we just finished the observation and question part. Oh no, observation, question, research, and the hypothesis part.
I think that's why it was it's good to go through this this document that the Ethical Skeptic has lined out here, because man, I love just how thorough it is.
Yeah.
And
it does ask questions that matter. I just realized it does ask questions that really do matter, that we don't actually think about all the time.
Yeah, I wish I would have finished it, but I was watching a TED Talk yesterday about well, this guy was claiming that the scientific method sucks. And so,
Recently, I've been hearing a lot about that too.
really,
Yeah,
what-
for example, Sabina is one of the
Oh.
like
yeah, Hoffenfelder, right?
yeah.
Sabine Hoffenfelder.
So
Check her out on YouTube. She got some great
yeah,
videos.
I am honestly a big supporter of Sabina.
Yeah.
She's more critical and she's more skeptical, even amongst the scientific community, and I like that. She describes a lot of the modern day cosmology models as what she calls mathematical creation myths. So it's self-consistent like a creation myth, but is it true?
I think she's one
Can it
of
be proved?
those. I think she's one of those people that's like on the pursuit of truth, and
She's more harsh on the and vigorous about the method.
yeah, and isn't worried about being wrong about
Yes,
things.
yes. And she's not afraid to criticize and be open about her ideas on how skeptical she is on that idea.
Yeah, so go check her out. But so what? So do you know what she says about why the scientific method is sort of is
So
crap, or-
she's not saying scientific methods crap. She's saying that modern studies are now more economically driven.
Ooh, yeah.
So it's driven by buzzwords. So for example, like I don't know if there's a good example. For example, a lot of let's say cosmology research, right? They are constantly moving towards grand unified theory, trying to unify all the four fundamental forces or all the particles, you know, or trying to fit everything in the theory of everything. There is another question: is that really the pathway to go? Is that really the way to go? You know,
Yeah, I don't know.
what if quantum gravity isn't about quantizing gravity? You know, like that's an example. You know, like are we questioning the directions that we're going right now? For example, Alzheimer's research.
Oh, yeah.
Is the what's it called? The tau proteins. They have a type of amyloid. Is the amyloid accumulation in the brain really the cause of it, or is it just just a symptom? You know what I mean? So people keep tackling modern day research on Alzheimer's is constantly I'm not saying everyone. I'm saying a lot of it that I've seen is tackling trying to treat the amyloid deposits.
Yeah.
But what if that's more of a consequence, not the cause?
Yeah, I mean, there's a lot of people coming out right now that have different opinions on Alzheimer's. And, you know, back to the economic thing is like they spent so much money, from what I've heard, they spent so much money on this one route that they're afraid of being wrong. And so they just keep pouring money into that same sort of route of trying to fight against Alzheimer's when it seems like it's definitely something else. And a lot of what I've been hearing is that maybe it could be related to like the plastics consumption in our body, the plastics in our body, the pollution that we have in the air.
Some find that it could be more of a mitochondrial issue, like maybe the mitochondria in the brain is not working anymore, and it started like causing problems.
But
Because the brain alone, keep in mind, the brain is, even though it's about 2% of our body weight, I may be wrong, but that organ consumes 20% of our body's energy. A lot of metabolisms going in the brain. So if there's a mitochondrial dysfunction, it could mess things up.
I need to look into it, but I think what I saw is somebody made a graph of Alzheimer and the use of plastics.
Oh yeah. I do recommend everyone to read this book. I got this. This book was. I found out about this book from again Sabina on one of her latest videos. But I've only read a few pages so far. But like it does seem very interesting. Rigor Mortis, and this book is by Richard Harris. It's called Rigor Mortis: How Sloppy Science Creates Worthless Cures, Crushes Hope, and what's the full name again?
Maybe it was some other
And worthless billions.
maybe it was some other pollutant or something, but yeah, you know, it's sad. Like, you know, I had my grandfather had Alzheimer's, and it is one of the saddest
Things to see.
in somebody to see that someone doesn't recognize you because their brain doesn't allow them to.
At some point, they don't even recognize themselves.
Yeah.
And I think that's a scary thing.
Yeah, and so, when my grandpa got that diagnosis, I don't think they really know if it's like genetic or where, how it sort of is passed along to people or whatever.
Again, it's correlation does not mean causation.
Yeah, exactly. And, I would like to go deeper into this but maybe another episode. Maybe we can do a little bit more research on this. And
Biophysics.
Yeah, I think this would be a really interesting topic because I think a lot of people have loved ones right now that are dealing with this, and it's really tragic. And the amount of people that are dealing with it just keeps going up and up.
Yeah, I agree.
And it's sort of like it's like cancer. It's something that we've been dealing with, but we haven't figured out some cure to it. And so it seems like there's something we're ignoring, right? Something that
I feel like it's more like we haven't been exploring enough alternative paths. Right now, for sure, compared to 40 years ago, cancer treatments and diagnosis is improved so much. We're now more able to catch cancer earlier, especially if you screen regularly, and we are better at treating most cancers.
Yeah.
Even the sequelae, which means by definition, sequelae means the post-treatment quality of life of the patient is getting better every day.
Yeah.
Because we are better at minimizing the side effects or the post-treatment side effects. But we don't have a silver bullet cure yet. We don't even know if it's even possible at this point.
Yeah, and apparently there's a lot of things that you can do to sort of mitigate Alzheimer's, like for instance, apparently like exercise, so brain health things, right? Things that keep your brain healthy, which your brain health is apparently correlated to your gut health.
I was just about to get into that actually.
Oh, wow. Okay.
So I have a friend's friend. He's in Malaysia studying in our national University of Malaya. It's one of the top schools in the world as well. And he's doing a research on using antibiotics to cure Parkinson's.
Oh, wow.
And the reason for that is because they found that a lot of Parkinson patients have similar microbiome signatures. So the brain gut axis has a very big effect on Parkinson's. So
yeah, I don't think that's what a lot of people don't realize is your gut health
what you eat matters so
is huge, right? That's why you need to eat right. You need to exercise, because, I mean, for me, anyways, I look at it like this. I want to not live a long time because, I'm vain or something. I want to live a long time because I really love the people in my life. And I want to be there as long as I can for
and
them.
be there with them and for them.
Yeah, exactly. And so my health depends on that. And so, after I heard, after we got the diagnosis of my grandfather, I started, doing things like taking lion's mane and other like
Supplements,
nootropics to help with the brain. But then I also try to focus on what I eat as well,
and what you do,
and what I do to make sure my gut is healthy, my brain is healthy, my body's healthy,
mental hygiene, all that, good sleep.
Exactly, because your body is a complete organism.
It's a
system. And if one system starts to go wrong, that can lead to all kinds of other things down the road.
Failure.
Exactly. And so you have to really focus on whole body and not just one thing.
Holistic or systematic approach, I would say.
Yeah. And, I don't know. I just think it is necessary if you want, especially like in our field, right, where everything is like mentally taxing. you want to make sure you're sharp like every day, because
Yep.
every day is a chance to like get further in your education, get further in your research, just get further.
Just healthier in general, better in general.
Exactly. And you can't keep pushing the boundaries if that's what you're wanting to do, right? Like I know that's us, right? Like
Yeah.
we want to like keep pushing the boundaries of what's possible, of of what we know.
Yeah,
And the only
intellectually and
only way to do
physically.
that is to make sure you're healthy. But yeah.
How
So,
could you take care of the world if you can't even take care of yourself type thing?
yeah, for sure. For sure. But let's get back to
Yeah,
the
get back into it. So
sort of a tangent, but
yep,
it's fine.
sort of a tangent. Next is inductive and statistical studies.
Okay. Inductive instant. Oh wait, did we skip
Oh, we skipped hypothesis.
Yeah,
Oh,
we.
wow, my bad. How do I mature this construct to a framing epistemic strength, one which features key elements of hypothesis? And what is the critical path necessary in evaluating or reducing this alternative to a complete alternative set?
Ooh. Reducing this alternative in the complete alternative set. Okay, so you're trying to basically boil down your hypothesis to the very basics.
The core elements.
Yeah.
The first principles.
Yeah, you're trying to boil it down to what is necessary to move forward. Is that a good way to say? So
boiling away the unnecessary details.
and so construct to a framing of epistemic strength, one which features the key elements of hypothesis. Key elements of hypothesis.
Well, time to click into the link.
Yeah, yeah. So
testability, parsimony, scope, fruitfulness, and conservatism.
So maturing the construct, move beyond a vague idea into a hypothesis with epistemic strength. That means it must include the key elements of a hypothesis, meaning clearly stated proposition, testable and falsifiable predictions, specific variables or relationships. Okay. And then so critical path for evaluation. Identify the most direct and effective way to test the hypothesis. Lay out steps for evaluating the hypothesis itself, comparing it against other competing alternatives, and reducing the set of explanations to the ones that best align with evidence. Okay.
I feel like okay, this is sort of a small tangent again. Okay,
go ahead.
I swear I'll keep the tangent low. But basically, what are your thoughts on like for example, do you think we can infer something that we cannot immediately study or test or experiment? For example, long time ago, someone already theorized the atom, right? Wait, who theorized the atom? So Democritus. He already theorized the atom way before we even know molecules exist, or even like just on a microscopic scale, right? But he already developed the idea of the atom. So, do you think that we can still do that? For example, can we infer whether or not there's actually a beginning of time or the edge of the universe just by postulates?
Thinking?
Or thought experiments, yes. Can we infer from what we already know? For example, let's say time, right? Some people say time has a beginning. Some people say time does not have a beginning. Some say the universe is infinite. Some say the universe has bounds. So, what do you think? Do you think we can infer that knowledge, or do you, since it's almost impossible to test?
I believe the mind is extremely powerful, and I also believe that the mind can think of things, and you can explore things in the mind that maybe you wouldn't be able to at that moment in time, right? And so, I mean, think about it. Like, he thought of that. I think even before then, I think somebody before in what do you call it? So ancient is not ancient Indian. What is the correct term for it? Eastern philosophy.
Yeah.
So they believe that they could basically answer all the questions of the universe just by thinking.
They use something called tetralemmas, if I'm not mistaken.
Tetralemmas?
Yeah.
Okay.
So instead of dilemmas, they have tetralemmas.
Okay.
Yeah.
And so they hypothesized about the most fundamental thing in the universe are these little particles, right? That make up everything. They only use their mind to think of that, right?
Like Democritus.
Yeah, exactly.
They didn't have microscopes. They didn't
No.
have anything that they can break things down further.
And then, you have Einstein coming up with his theory of relativity through thought, what do you call them? Thought experiments, right? And so I don't see why we couldn't keep pushing further in that realm to come up with things. I mean,
I feel like that's how we come up with things, right? We imagine it 1st, then we can build a model to test. Einstein created special relativity just by imagining it. He did not literally ride on a beam of light. He imagined it. So I feel like, based on this premise, I feel like people should ponder more about quote unquote impossible problems. We need to, like, for example, is time infinite? How do we know that? Is there a beginning of time?
Yeah.
But yeah.
Yeah. So I'm always I'm always baffled and just sort of like thrown aback a little bit sometimes whenever I think about the things that I've accomplished in my life. Because no, they aren't. I didn't build a Tesla or
Tesla
a
coil.
SpaceX or but to me, I've been able to accomplish quite a bit just through sort of thinking positively about things and following my curiosity. So sort of, I don't know if you could say it this way, but sort of following my consciousness, right?
Yeah. Following your curiosity.
Yeah. And I don't know. I don't know where that sort of essence comes from that's given me the energy to do that and sort of given
That drive.
I don't know where that's came from. It seems like it's somewhere deep in the mind, right? And so
Depending who you ask, they'll say it's your dopamine center.
yeah. But I don't know. It's just I find that there's something there that's maybe not unexplainable. Maybe someday we'll be able to explain it. But to me, at this moment, there's something unexplainable that's gotten me here today. Right? It doesn't make a whole lot of sense to me.
Some call it fate.
Yeah, you could call it a bunch of different things.
Some call it free will.
Either way, I'm pumped for being here.
Yep. Grateful to be here, where we are today.
Yeah. But anyways,
back to
next one.
Yeah.
So are we? Yeah, we're past hypothesis. We get what a hypothesis is.
Pretty sure.
Yeah.
Inductive and statistical study, and I mean, this is pretty straightforward. At least for.
Oh.
Yep.
What I was gonna say. Okay, to hypothesis.
Yes.
So that something came to my mind about that video that I was talking about earlier that said that the scientific method is crap, or actually he said it sucks. And so he was talking about that. He was basically using the scientific model that we were talking about earlier. That's like very basic and very broad. And I wish I would have watched the video because then I could have like further been able to understand where he's coming from. But he was saying that like, okay, well, it sort of tells you to make a hypothesis. And he's like, well, what if you don't even know what a hypothesis is? What if you don't even know like how to form a good hypothesis? But I think that's what the skeptical ethic is sort of helping us do, is sort of like getting us sort of
Asking
primed.
quality questions.
Quality questions so that we sort of are able to form a better hypothesis, right? So, maybe there's multiple forms of the scientific method. They're not all created equal, and you shouldn't stop at just the first thing you come to. You shouldn't, Google it and you see like the 7-column thing that we saw and stop there.
You should always ask, is there something deeper? Is that it?
Yeah, because there's always I am always sort of blown back whenever I realize how complex a topic really is.
I'm on the bandwagon of infinitism. So basically, there is a school of thought in epistemology. It's called causal infinitism. Basically, it's trying to say that there's infinite. You can go infinitely far back of the causal chain, and also infinitely small in every scale. So that means there's infinite things to learn about a system of how it works. Of course, knowledge can be generalized and all that. But
it does. Yeah, I mean, it definitely feels like for instance, whenever I first started going down the rabbit hole of physics, it felt like, oh my gosh, like it's a bit overwhelming. You sort of. And that's just at surface level. Once you start to go deeper and deeper, you're like, oh my God, where does this end?
Yep.
But that's why I think like something like ChatGPT or AI is like really great, because it allows you to just keep going deeper and deeper and deeper into that hole,
Yeah.
And that's one of the things why I really enjoy using AI.
Yeah, I feel like an interesting note though. I feel like the main precursor to the scientific method is the Socratic method. And basically, Socratic method is just Socrates' way of he calls it a method of inquiry. Ask and use questions to look for contradictions, and the contradictions is what leads to a what's it called?
Contradictions
Leads to is to show that a model's incomplete. The thought is incomplete.
Oh, if you find a contradicting
proof by contradiction.
Oh, okay. I see. Like a falsification.
Yes. And his goal is to bring people to a state of what is it called? A state of, they call it healthy confusion, where it leads the person to ponder further.
Interesting. So I have to bring this up, and I know the way that we've been going about the scientific method is not necessarily chronological. It doesn't feel like to me anyways. I mean, we sort of are, right? But I think we left one thing out. And it was funny because I was talking with Prather yesterday, and he was like, be sure to like
bring it up.
Lead with this. He said, lead with observation.
Yes.
And I was like, I kept trying to think of like, oh man, what was that thing that he was talking about? But I finally remembered it, observation. So I think before we go further, we should talk a little bit about observation, because to me, and this is, I think, sort of linked with epistemology, right? Because
how we know what we know.
Are our observations even good enough to come up with good hypotheses? Like, for instance, sometimes our eyes deceive us. And then there's like the measurement problem.
Parallax error, for example. Like how different angles could make something look very different.
Yeah, and so,
that's why science developed tools and measurements to try and make measurements and observations more consistent. I feel like the hallmark of epistemology and ethics is consistency. Is it logically consistent? Is it consistent with evidence? Is the evidence consistent with reality, or at least existing models of reality? And also, is it ethically consistent? I think consistency is the hallmark of scientific model.
Yeah.
Just because we have consensus that it's right doesn't mean it's right. Just because a million people say dumb things, it's still dumb,
Yeah.
Like, it's the consistency, whether it reflects to reality, the observation, or whether it's logically consistent. I think that's very important.
Well, there's, the whole question of like, are humans, do we have the capacity to fully understand the universe?
Actually, that's where I wanted to bring. So you know how just now I was talking about thought experiments. The reason why I brought it up, I was actually trying to get you to think about this. We can model the universe only so much because of our senses. For example, if you're blind from the start, the idea that as something's further away, the smaller it looks, does not intuitively click to a person who's completely blind from the start. They don't understand that. You know what I mean? They don't understand the idea that and it's, when something's further away, it's blurry. They don't understand that. They can't understand that. Even the idea of a horizon, where something's far away enough, it's just a line. They cannot understand that. So that comes into the modality. It's also proven with AI. The more modality it is, they're better at reasoning, at least in some aspects. So do you think that with our limits of imagination, because of our limits of our senses, there are certain models that we just cannot reach because we cannot imagine it. So this is more of a neurological, what I like to call cognitive blind spot.
Yeah.
Our blind spot to our mind. For example, hyperobjects. I brought it up last time, right? Hyperobjects are things that span in time and scale that humans cannot grasp in an instant. It's not localized, it's spread out. For example, climate change is considered a hyperobject. The internet is considered a hyperobject. It's something humans can't like weather is a hyperobject.
Is it like because there's like chaos and complexity in it? Is that
Oh
what
yes. So high complexity is one thing. Second thing is it's not localized. It's not a singular concrete object.
I see.
It is something more sparse in both space and time. Like climate change happens globally. It's not like local weather where it's rain only here, rain only there. That's easy to point out. Rain. What's rain? A specific event. Climate change is a global event. It's hard to pinpoint here and there, here and there, here and there. It's collectively over time we build a statistic model to show. That's also why so many people struggle to believe climate change is because they can't form a mental model around it. You know what I mean?
Yeah. Well, I don't know. Yeah, climate change is a weird one, because I mean, there is evidence, or apparently there is evidence that the climate throughout Earth's history has changed dramatically in multiple times. We have the Ice Age. And then there's other times where apparently the Earth got really hot and then really cold, and it's just like, well, have we even been able to collect enough data to really know how the Earth breathes, right?
That's actually a very brilliant question. Polar ice caps. So what scientists found out is the carbon concentrations can be measured and is trapped in ice in the polar ice caps. And the deeper you go, the older back in time you go. So scientists were able to go through hundreds of feet of ice. I think even down to like more than that. And they measure carbon concentrations in each layer. And they are able to plot a chronological timescale of how carbons fluctuate. And it is accurate with the ice ages, with the different extinction events, and those would associate with an increase or decrease in carbon and oxygen levels, right? But what they found interesting is our carbon levels today still outnumbers prehistoric levels.
Really? Wow.
Because the difference is back in the day, the carbon cycle, all the carbon that's in the air either came from the volcanoes, which brings it from underground, or surface stuff that decayed, right? But volcanic events is very rare. And oftentimes, life finds a way that we often find it back to carbon sinks, like under the ocean or under the ground. But humans are special. We started digging it out from the ground. So just imagine a volcanic eruption that's constantly happening. That's what we're doing. We're releasing billions of tons of carbon every year. But volcanic eruptions rarely happen.
Interesting.
So,
I've also heard though that there's a lot of carbon emissions. I think it's yes, or CO2 that comes from the seafloor.
Itself. Yes.
Yes, and ends up in the air somehow.
That's part of the carbon cycle. And if you didn't know, most of the ocean is made from carbonates and also carbonic acids and whatnot. But here's the interesting thing. Whenever you look into climatology, they have words like tipping points. What do they mean by that? So once the atmospheric temperature reaches a certain point, it creates a feedback loop that will not allow us to reverse it anymore. So for example, the one feedback loop is, like I said, carbon's trapped in the polar ice caps. A lot of carbon is trapped in there. If we reach a certain temperature where most of the polar ice caps melt, it releases so much carbon that we cannot reverse it anymore, because now that it's released, it's only gonna heat up further. The ocean is the same. As you heat up, have you tried warming a can of soda?
Oh, I mean, no, not really.
Well, yeah. But basically, it will when a fluid temperature reaches a certain level, it releases its gases or allows it to capture more gases. But another problem is as the air gets more carbon and more acidic because of all the emissions, right? All the fumes. The oceans get acidic, and the acidity will erode the carbonates that is stored in the sand and in the shells of the animals. That's why we found that a lot of shells of animals are getting thinner. It's leaching the carbon and the calcium carbonate from the shells itself, from the animals. So that leaching releases even more carbon. You see, so we call this the runaway effect. This is what scientists mean when they say the tipping point of certain climate change benchmarks.
Interesting. Yeah, I mean,
This is the
that
carbon
is a
cycle.
huge. I mean,
That's ecology.
I would. Yeah. I mean, I would love to.
Oh, we could invite people from the, the meteorology center that we can invite them to talk about.
Okay. Yeah.
think that would be
I would
crazy.
totally be down.
Yeah.
I mean, that is a. Oh my God, that's especially in today's day. It's like that's a huge topic, and it's one that you don't really get a lot of people that agree. There's people who think that climate change is a complete hoax. People that think that it's like
it's a problem, just not that big of a problem.
Exactly. And then there's some people who think that the world's gonna end tomorrow because of climate change. This is why I think like we just got to do the science. Let's do the science. Let's show the.
Where does the data bring that?
Yeah, exactly.
Anyways,
so we were talking about the observer, right?
Yep.
So a couple of different things to watch out for. So there's like the observer bias, right? So we tend to see what we expect to see. And that's why
blind studies, placebos, and whatnot.
Witnesses are important, and so it's good to collect the data through instruments and things like that. Because if not, we can't just rely on one person, right? Like we can't rely on one person to say, oh, "I saw a UFO," and like, okay, well, everybody now believes in UFOs. No, you have to
set up cameras.
Yeah. You need more than one person
and more than one camera for sure.
Yeah, exactly. Confirmation bias at the observational level, selectively recording only data that fits your expectations, cherry picking. This happens a lot, and unfortunately, it happens a lot. Happens in academia sometimes.
Yes, I agree.
I understand, right? There's the human element, right? Where
we want to be right.
And not only that, but you need to put out work. You need to publish, especially if you're at like a huge university that's expecting you to publish so many papers per year, right? And is looking at I forget what they call it, but it's like the
citations.
The citations, but it's like a mark of like how not relevant your research is, but like how impactful it is. It's like the impactful level or something like that.
The impact level, yeah.
But and so I get it. Like you've got this pressure on you, and you need to publish, or else maybe you're gonna lose your tenure or something.
Lose your grant.
Yeah, lose your grant, but at the same time, I think stories like that is sort of what makes people sort of hesitant on believing in the science, is that okay? Well, but what if some science is fudged, and we know this now, and
Yes.
so that's why it's up to us, up to the future scientists to try to do real and good science.
I feel like that's also what makes science beautiful. And I always quote Carl Sagan, which he says science is more than just a body of knowledge, it is a way of thinking. It is combining skepticism with observation to make sure that we back our claims. And I feel like because today we always try to cite our work, and every time we cite our work, what do? We search up only things that align with our work. And I think that goes back into confirmation bias. But because since there are so many people that are skeptical, that's the beauty of science, that when someone publishes something, everyone else is like, is it true though? And that's where we self-regulate.
Yeah. I want to keep reading these things. I feel like we need to get back on track, but I still think these are good things to think about. Instrument limitations, right? Like, man, and our instruments just keep getting better and better and better, right? Like the things that are coming out of the Webb telescope, right, are apparently like pushing
The limits
of our models
of astronomy,
yeah. And so yeah, it's going to be interesting to see what else comes out of that.
I did the same mistake last time. I
That's
did not.
hilarious. You're good, no worries, man.
Every time.
Yeah, so you have to, that's why they're in instruments. There's always some error, right? That it's expected. Are you all right?
Where's my other phone?
I have no clue.
Oh, it's right here.
Okay, cool.
We're good.
Two phone dude over here.
My bad.
I got two phones.
I just want to make sure both are muted.
Okay, I feel you.
Okay. No more mistakes.
Yeah.
Now.
So let's see here. What else? Misinterpretation of anecdote. We've sort of already talked about. So a single observation does not equal proof. Yeah. Context dependence. Observations need metadata, time, place, method. An observation without context loses scientific value.
Yes.
And then last, ethical use of observation, especially in medicine, biology, and social sciences. Observing subjects must respect ethical boundaries. Looking can itself cause harm if not handled responsibly.
Yep.
Looking can itself cause harm.
For example, this is more towards ecological research. So when scientists try to study animals in the wild, for example, they accidentally leave lights on, not knowing that those lights can disrupt the night cycles and the nocturnal life. Or they use infrared light, not knowing that some animals can see that, type things like that. Yeah.
I see. Oh, well, and then like what is it in quantum physics where observation sort of changes the state.
Oh yeah. Okay, but
what is that called again?
Collapse of the wave function. Decoherence.
Okay. Yeah.
So I do want to point out, decoherence is not talking about something special about the consciousness. It's just that quantum particles wave functions are so fragile that any interaction at all from the outside world can disrupt its wave function. We're not talking about how consciousness is so special that it's going to change its wave function. No, it's just noise. Any noise from the environment can disrupt any wave function.
I mean, it makes sense, right? We're talking about the quantum level here.
The smallest particle, bro.
Yeah, of course, something coming close to it is going to interact with it, right? I mean, I would. We definitely need a quantum mechanics.
We do need an episode. Also, just a fun fact: do you know that they've done the double slit experiment for something up to few hundred atoms?
Oh,
so like molecules.
Oh, wow.
So they are not firing electrons through the Thomas Young experiment. They did it with like buckyballs. With few hundred atoms.
Interesting.
Well, I wouldn't say what like 8 C60.
Okay, and they're still are they still getting the same
interference pattern?
Interference pattern. Wow. I mean, it makes sense. Why you would still get the? Do you want to elaborate on why maybe?
So basically, so what they do found interesting is that when the more massive something is, the smaller the wave function, the more narrow it is. And also another thing is the more velocity you have in that particle, the smaller the wave function as well. So like the thinner, the smaller the wavelength of the wave function. So the interference pattern will be more squished, right? The frequency will be higher. So what we found is, yes, it does happen in smaller and smaller scales, but it's also more susceptible to noise, which is counterintuitive. You would think something bigger would be less likely to be interfered, but no, it's more likely to be interfered and it also, these systems have to be cooled as well.
Okay, so in doing the experiment, you're saying they have to be cooled.
We don't want like.
Oh,
Here's the craziest
temperature.
part.
You don't want
Yes.
temperature. You don't want extra energy.
Yes.
Yeah.
Here's the craziest part. The temperature of the object itself could interfere itself.
Yeah.
And that would change the outcomes.
Yeah.
We call it self-interaction.
Interesting. I didn't even think about that in like the original Young's double slit experiment. I wonder.
And that's also why I'm criticizing on the Copenhagen interpretation.
Yeah.
Are you telling me the atom actually goes through both slits? If you're telling me like quantum fundamental particles go through, okay, sure, fair game.
Yeah.
Entire molecules going through both slits at once, nah. I'm calling it quits. I'm tapping out on this one.
I wish.
The Copenhagen interpretation and to me, it's intellectually dishonest because you're brushing the shut up and calculate mentality. Is not helping us tackle the ontological problem.
Well, and if I were to push back a little bit on the Copenhagen interpretation, is Niels Bohr is one of the proponents of it, right?
Yes.
And he was known for sort of, I don't want to say he was married to his ideas, but it did seem like he was the kind of guy that thought his ideas were the better ideas. I've read a lot about Niels Bohr.
Until Schrödinger comes in.
Yeah. But, he was also like, to me, Niels Bohr is one of the most interesting characters in the history of science. And the main reason for that and why I believe that is because he was instrumental in bringing like the sharpest minds, the most the biggest minds of that time, the brightest minds at that time together. Like he was totally instrumental in doing that. He was a guy that, and he was also apparently like he had this house where, he would invite people, the people that worked, intellectuals that worked around him, and they, just hearing about the different conversations that were happening.
I feel like that's so fun though. Just having a party while everyone's geeking out.
Yeah, a nerd party.
Yeah, nerd party.
I love it.
Oh my god, we need that. Yeah.
I mean, that's kind of what this is.
That's kind of what this is. That's kind of what the society is about.
But also Bohr was a very, I want to say, like, he didn't really, it seemed to like put up with anybody's shit. Like he seemed to really think like his ideas were true. I mean, I get it, you spend this much time on something, you're like,
this must be it.
The world's leading expert on this thing or whatever. And so,
I mean, to be fair, even Schrödinger, when he discovered the wave function, right? He was criticizing his own work because he hates the idea that we need complex numbers to describe reality and whatnot. I feel like that being self-critical and self-skeptical is a healthy measure of science.
Sure. Yeah.
And I don't think Niels Bohr can get to where he is without being self-critical.
Yeah, no, most definitely.
Yeah.
No, most definitely.
But I think having high confidence in your work.
I think that's what it was. Yeah. Is its confidence for sure.
He knows what he's talking about, and I still believe that obviously Niels Bohr does accept criticisms because otherwise he would not drop the Bohr model and he wouldn't have hopped onto the Schrödinger models.
Yeah, and apparently him and Einstein went back and forth on things all the time and disagreeing a lot on all the time, and so that shows you that he just even spends that time with Einstein and arguing his ideas, that he's willing to hear somebody out, you know,
Exactly.
which I think is a good
The
quality.
backbone of science.
Yeah, for sure.
Scientific.
But I feel like we're getting sort of long in the tooth over here. 2 hours and 32 minutes in. So let's
Finish that up.
Oh my gosh, there's still so much stuff. I don't know why, but I just sort of knew this was gonna happen. Like, but
I knew it's gonna happen if you told me you want to go through like
yeah,
individual
yeah.
proponents of this. Because I thought we were, because that's what I was thinking is we're supposed to go through like the history of scientific method,
Yeah.
like epistemology,
Yeah.
the different schools of thought, how they started studying.
Yeah.
So that's what I thought we were going through.
Yeah, and I wanted to do that too. I sort of got distracted a little bit, and then also at the same time, you know, got so much going on, man, and
Yeah, I got you.
it's really hard to prepare, like really prepare for this, which I wanted to. It's just really hard, but especially with the sort of depth that we really want to get into things, right?
Yes.
And I don't want to sort of.
I feel like going too deep would be like, I mean, it's a good thing going deep into a certain topic, but like,
Well, I'm sorry, try to cut you off, but
Yeah.
maybe this could just be our like scientific method, like the actual scientific method pod, and then we could have maybe a history.
yeah, so more general,
Yeah.
like general.
Where maybe
Study
like
method.
further down the road, where we've sort of been able to have time to sort of read more about the history of it and have more of a framework in our heads about it.
Yes,
to
yes.
be able to, because
I feel like the podcast needs some level of organization. I don't
Yeah.
think it should be too strict. I
Yeah.
still like the casual on the fly type thing, but I still do believe we need some level of structure.
yeah. Well, so okay, so then what? How do we want to? I would say.
Okay, how about this? Okay, I think this will be fun. If it's, let's just say if it's only just two of us, we do alternative picks on topics. So like this week it'll be a topic that I'm hosting. I'll be bringing up questions and answers. More, I'm the prompter.
Yeah.
You're the oracle type thing, you know. And then the next time you look for a topic, right? And then you be the prompter, I'll be the oracle. Just like back and forth, back and forth.
But that just goes back to like, do we have enough time to be like an oracle?
No, in a sense that it doesn't have to be, like I said, we need a general structure. We don't need a specified, like, because if we get too deep and specific,
I don't know.
it might as well be a study.
I mean, we can always do a second round of this, right? We could all do like first half and second half, right?
Like a part 2 for scientific method.
Yeah. So like we could go through this, right? We basically. I feel weird because it's like it feels like we've only gotten like really halfway through.
Yeah, no, that's the point. That's my problem. So like we have not really touched on.
So yeah, we could do like, okay, so this one maybe is the first half, and then we could have a second half where we just go right back into where we left off, right? And then we could have maybe one that's just about the history. I don't know.
I feel like this dives more towards ethical, scientific ethics. I think this is more scientific ethics.
Yeah.
And then another episode would be more towards history of scientific method.
Yeah.
And another one would be more of just ontology, epistemology, and all that.
Yeah.
I think these are more better, broader categories that we can go into.
I think the best part of it is I think we're learning.
Yeah, we're figuring things out. To be fair, this is just the third episode.
Yeah.
We're trying to figure how to
Well, no, it's the
structure it.
fourth episode.
Oh, you're right.
Yeah.
You're right. Yeah, this is the fourth.
The unpublished pre-pilot.
Yeah.
The lost episode.
Yeah. Someday you guys might get it.
Yeah, I don't know. I was thinking about handing it off to Brody and sort of have it for him to sort of just mess around with.
Because what I'm thinking is, I want to be fair to everyone, as well as even to whoever's editing in post-production, like Brody, is that if we have some general structure, he knows where and what to do. And it's easier to pinpoint a timeline as well. mark where and when what we're
I
talking
see
about.
what you're saying.
So it's easier for him to keep track too.
Yeah.
But because right now it's so everywhere.
Well, I think I think the reason for that is because we're not experts.
Yes, but also we don't have much pre-planning on the topic. That's why I feel
Yeah.
like if we have this back and forth thing, like one day I'm preparing the topic so that I can help make sure we're staying in scope. Next time if you prepare it, we can stay in scope.
Yeah.
And
Or maybe it might be better if we work on it together, right? So
and sometimes we can do it together. But I know for a fact that there are some things you're better at.
I see.
You know more about. I could still look into it
I
for
see
the
what you're
knowledge,
saying.
but you
Okay.
unless because we don't meet that often.
yeah.
Unless Tuesdays and Thursdays,
Yeah. Okay.
and even then we rarely meet. So
Okay.
sounds
Okay.
good.
Okay, so then what do we want to do from here? Do we want to wrap up? I mean, it's what, almost 4:00.
It's 5. It's almost
Yeah,
4.
4:00. I say, I don't know. Okay, so I say we pause on.
Pause on this.
Yeah.
We could go. I guess we can technically put this as ethical, scientific ethics.
Yeah.
Right, and then the next episode we can either do scientific ethics part 2,
Yeah.
finish this up, move into the history,
Yeah.
or we can plan from there.
Yeah, I mean, because I honestly, I think what we
Because I
went
like
over,
this topic.
Yeah,
It's just that
I think what we went over today is really informative.
Yes.
Not only
too
for me, but hopefully the listener. But I think we'd be doing it disjustice by trying to run through the rest of it.
exactly.
Yeah.
I agree.
Okay. Cool. I mean, again, I want it to be as organic as possible.
But while keeping touch.
Yeah.
Like keeping grounded.
I feel you.
Yeah.
I feel you. Cool. So I don't know. Is there anything else you would like to say, or is there anything you're looking forward to in the semester?
What I'm looking forward to in the semester is once the lecture series starts coming back.
Yeah.
And
oh my
also,
god, I gotta
like,
start working on mine.
yeah, I already need to start working on mine too. And I'm also looking forward to having more guests in the future.
So maybe talk about like what it is your talk is going to be over.
Oh, okay.
Have you talked to Dr. Teo? You should probably go.
I have not.
You need to
Yeah.
probably go talk to.
Yeah,
Dr.
I need to write an abstract, send it to him. But basically,
Or just go talk to him about your idea and what you wanted to.
my talk.
Yeah.
Okay, yeah.
That's what I did.
Okay.
I just went into his office like, hey, this is what I wanted to give mine over, and he was pumped about it.
Okay.
Yeah.
So my topic basically is on particle physics and the frontiers of foundational physics.
Okay. Cool.
So like how we discovered all these particles, how we know what we know about these particles, and what's next, what's missing, what's incomplete about our model. The standard model is the one that everyone buys, but
Yeah.
how do we know it's right?
Yeah, we keep keep smashing particles together, and it
That's our
doesn't seem-
philosophy. Our philosophy is to do something first, ask questions later.
Yeah.
Particle physicists call it smash first, ask questions later.
Yeah,
So
yeah,
I like that.
Yeah, yeah. Yeah, I feel like I don't know. Just as a group, I think we have like a lot of.
We need to put that on a t-shirt.
Yeah,
Smash
Yeah.
first, ask questions later.
that would be hilarious.
Yeah.
So, okay. So, what to you was like sort of like the most interesting part of that? Like,
On the topic that I'm going to look into.
yeah.
No spoilers, but I think the most interesting part about particle physics is the fundamental forces, and why I think we are we too vaguely define how fundamental forces work.
Okay. Interesting. Okay, so yeah, my talk is going to be over. I've talked to you about this exact solutions and sort of why they matter. So my thought is, okay, why is this interesting? Why is this necessary? Right? My thought is, well, we learn all these things in school, right? And all of us just sort of, anyways, I assume like, okay, well, I'm going to learn all these things so that I can go to a job and apply these things that I've learned. Well, what about if you want to apply these things on your own? And I think that's what exact solutions can be. It's something that you can do based off of the knowledge that you've gathered through your schooling.
Ooh.
And so I think it'll sort of, hopefully open people's eyes to maybe what else is possible with a degree. You can go into modeling,
Yeah.
right? Which I think is one of the most fascinating things.
I have a question for you though. I'm pretty sure we talked about this with Dr. Prather. Do you think there is an exact solution for any system or any problem? Because some
That's a
people
tough
say
one.
it's intractable, even if there is, and some people say it's just not possible.
Well, from what I've read and seen so far, is that exact solutions are based off of, and I love this word, it's based off of rigid models. So models that don't have a ton of complexity in them, right? Whereas like, let's say a climate what'd you say?
Climate model?
Climate models, right? There's so much complexity in there that it doesn't seem, to me anyways, it doesn't seem like there's going to be an exact solution to the climate model, right? You're not ever going to be able to predict for sure it's going to rain today, right? You're not going to ever be able to be 100% on something, right? And so, yeah, I think that, we use these models to sort of try to explain physical phenomenon, but they are very mathematically rigid, and I don't. They may explain physical phenomenon, but that does not necessarily mean that they are a complete view of that phenomenon. Does that make sense?
Yes. I do want. I think that's something that you might like is. I think you should look into effective theories. So
okay.
it's the opposite of exact solutions. And for example, sort of like an exact solution would be like quantum mechanics, right? But we apply quantum mechanics in the standard model, right? Which create effective field theories, which is, for example, QFT, quantum field theory. That's an effective theory. Or another example is we know how temperature works. It's just the average kinetic energy of the particles bumping into each other, right? It's kinetic theory. But an effective theory is just thermodynamics. It's just to talk about the average temperature in a room, for example, or of a system.
Yeah.
Instead of looking at every individual particle, effective theories look at more broader general terms.
So yeah, so to sort of add to what I was saying, so for instance, there is an exact solution to the 1D and the 2D Ising model, right? And the Ising model is a model that models magnetism, and it does it in a very basic way. So you only have, so each atom in a crystal structure, crystal lattice. So let's say you have a very basic crystal lattice. Let's say it's 1D. So you have an atom, and then an atom, then an atom,
It's a chain.
in a chain. Yes, exactly. 1D chain. Right. So we have an exact solution to that model. Right. And then we have the 2D, which is, you think of
A plane.
Exactly. So you have, it's no longer a chain. It is sort of it's a square.
It's a sheet, yeah.
Right. And so on each point of the square, you have an atom, right? So in this 2D model, we have an exact solution for it. Well, actually, there's not really an exact solution to the 1D model, but anyways, but then the 3D model, which, oh, I forgot to say, so each atom can have either a spin up or a spin down, right? Meaning that the magnetism is sort of pushed to one direction, either up or down. Right? And then whenever you have all of these pointing in the same direction, you have an overall magnetism.
Or a domain.
Whenever they are randomly oriented, you have zero magnetism. Right. And so then you think about, well, materials aren't really necessarily, well, actually we are coming up with 2D materials.
Yeah.
There's,
you
graphene, right?
or molybdenum sulfide.
Yeah, but most materials are 3D, right? And so that's what we want to do in the 3D easing model is model real materials, but that sort of adds a level of complexity to the system that we only can find an approximation to the solution. We can only find an approximation for the solution, which the solution would be sort of how the phase transition looks like. So how the graph of the phases of magnetization look like in a 3D.
In overall.
Yeah. Yeah. But adding this third dimension, for some reason, only allows us at this moment to get an approximation
But
to the
similar,
solution.
don't you think it's similar to the three body problem?
Yeah, I mean, there is that.
Like problems starting from three bodies or three dimensions and above, things just seem to start getting so chaotic because of the possible degrees of freedom.
Yeah, well,
Scales faster.
yeah, and that's one thing that I want to sort of tie the talk up with is do we have the tools necessary to find the exact solution to a 3D model? And if not, will we ever find a solution to the 3D model? So I'd like to explore that. I'd like to explore some of the math, the types of math that are used in finding exact solutions, because I think that's sort of eye-opening. The Ising model uses like quantum mechanical transfer matrices to come to the exact solution, and I'm sure that there's models in chemistry, models in other like biology. I'd like to explore like what is the math they use in their exact solutions or their approximations. And yeah, so that's what I'm gonna give my talk over.
That's awesome. I'm
Yeah,
excited.
yeah. One of the things about models is a lot of times you can only get a good approximation.
I mean, like what George E.P. Bach said, right? All models are wrong, but some models are useful.
Yes, exactly, and that's so fascinating to me that we can only get an approximation, and some people spend their whole lives just trying to get a better approximation, not necessarily an exact solution. They just want to get the model to be able to predict a little bit better
Than before.
Yeah, exactly.
Incrementally.
Yeah. And I think it may tie into machine learning a little bit as well. I'm sure it will. And so, with the advent of machine learning and how big it is nowadays, I think I'd like to try to also explore that in my talk as well. I don't know how exactly I'll tie it in, but yeah. But yeah, anyways.
Yep.
Anything else?
No, not at the moment. But yeah, I mean, do you have any rough idea when the lecture series is gonna start? Are you gonna tell that? To the viewers?
Yes. So it's either going to start next Thursday or the Thursday after. Yeah.
And will we post the recording?
Yeah, of course.
Okay.
Yeah, we're gonna record it. Actually, Brody talked about trying to be there so that he could be the one recording it, which would be awesome.
Even better.
Yeah, for sure. So we're gonna be putting out more content. Our idea is just to try to expose as many students and many people as we can to new ideas, different ideas,
And give them a platform to share either online or offline.
Yeah. We want curiosity to thrive, and so not only are we trying to put out more videos and content. I don't know, for some reason the word content to me sounds weird, but but we're also getting better at it, right? We've got people now who are going to school for that sort of thing and more passionate about it than, I mean, of course I was passionate about it, but at the same time, like, I'm very novice at it and just trying to get it done and get it put out. So.
Yeah, that's true.
But anyways, I think we just wrap it up.
Yeah.
All right.
Until next time.
Until next time.
Yeah.
All right, bet. It's hilarious.